two identical billiard balls A and B collide. Okay. So this might be the billiard ball A with a mass M, and there's another billiard ball B. After a strike, these balls collide. So by the strike, A might have received the velocity and it's moving towards B, which is initially at rest. Then what will happen? They are collided, and while B came into a velocity of 6 meters per second after the collision, all B moves at 30 of its original direction, and all ball A moves 60 the original direction of B. Okay. In a billiard game, after a strike by the player, so he has given the strike to the ball A, two identical billiard balls. Both have the same mass. A and B collide. Ball A was initially at rest, while B came into it with a velocity of 6 meters per second. Okay, so this is the way. Ball A was initially at rest. While ball B came to ball A with a velocity of 6 meters per second. 6 meters per second. And after the strike, after the collision, what happened? After the collision, ball B moves at 30 to its original direction. After collision, ball B, now the collision is finished. After the collision, ball B, so this is the original direction. And with respect to the original direction, ball B moves at 30 into its original direction. So this is the new direction of ball B. Let's say the velocity is VB dash. Angle is 30. And what happens to ball A? Ball A moves at 60 to original direction of B. Ball A moves at 60 to original direction of, here it's 60. Let's say the velocity is VA dash. Find the velocities A and B after the collision. So you have to find VB dash and VA dash. So this is the situation. In a billiard game, two identical balls, same mass, M and M. Ball B is reaching ball A with a velocity of 6 meters per second and hits the ball A, which is initially at rest. Then what happens? After the collision, ball B and ball A move in separate directions. If we consider the ball B's initial direction as the original direction, with respect to the original direction, now after the collision, ball B has moved to a direction where it creates an angle of 30 with the original direction with the unknown velocity, let's say VB dash. And what has happened to ball A? After the collision, ball A has moved in a direction which is creating an angle of 60 with respect to the initial direction of the ball B. So you are asked to find these two new velocities. So these are the questions. Question number 25, 27, 28, 29, 31, 33, 24, 23. Now there are two unknowns. We don't know the final velocity of B and the final velocity of A. So as there are two unknowns, definitely we have to use two equations. From a single equation, we can't find two unknowns. So at the end, if you are going to have the answer, we need to have two equations. So what are these two equations? What's the method? This is my plan. I hope to apply the linear momentum conservation in the original direction as well as the perpendicular direction to the original direction. So this is my plan. I'm going to apply F equals ma to the original direction and to the perpendicular direction to the original direction. So my first attempt is to apply linear momentum conservation. Apply linear momentum conservation to the original direction. To the original direction. I'm going to apply linear momentum conservation to the original direction. So before the collision, the linear momentum before the collision can be equalized to the linear momentum after the collision. Okay. Before the collision, what are the component? What is the linear momentum before the collision? Ball B is having a mass m with a velocity 6, m into 6, the velocity. Plus ball A is at rest, so m into 0. So these are the two momentum components before the collision. From the linear momentum conservation, the momentums, the addition of the momentums before the collision is equal to the addition of the momentums after the collision. Okay, before the collision, momentums are m into 6 and m into 0, as this is initially at rest. After that, I'm applying LMC, linear momentum conservation, to the original direction. So what are the momentum components in this situation to the original direction, after the collision? Now, this ball B now moving with the velocity VB dash to a direction where it creates an angle of 30. But consider this, every vector, you can resolve the vector into two components. If so, if this is VB dash and it creates an angle 30, I can consider the vector component to the original direction. I can consider the vector component to the original direction. If it is VB and if there's an angle 30 with the original direction, what is the vector influence or the vector component to the original direction? VB dash cos 30. VB dash cos 30. I can use that vector component to write down the momentum in that direction. Okay, so before the collision, m into 6 plus m into 0 are the momentums. After the collision, I can use this mass m with this vector component, VB dash cos 30. It is the momentum component to the original direction. Okay, m, it's a scalar, it can be used in any direction, but VB dash in this special direction. You take the component VB dash cos 30, it is in the original direction, m VB dash cos 30. What else? There's another ball A. It's moving to a direction, creating an angle 60 with the original. Okay, I will take the vector component VA dash cos 60. VA dash cos 60. Okay, VA dash cos 60. So, M VA dash cos 60. Okay, now I have applied linear momentum conservation to the original direction. Before the collision, m into 6 plus m into 0. After the collision to the original direction, velocity components are VB dash cos 30 and VA dash cos 60. So, m VA dash cos 30, m VA dash cos 60 are the momentum components. So, I have applied LMC in the original direction. So, here m will cancel out, 6 is 6 is equal to VB dash cos 30 root 3 over 2 plus VA dash cos 60 half. This is my equation X. Now I have received the first equation. Now to find two unknowns, I need two equations. Now I have one. Now I have one. Now last week we did these basic questions. They are not enough. We have to go for the further problem solving in each and every lesson. So today we are starting with the linear momentum conservation with the 25th question. Now we are in the 25th question. Okay. In the 25th question, this is the situation. It's about a billiard game. A billiard ball B is used to strike billiard ball A. Billiard ball B moves into a certain direction and it collides with ball A. After the collision, ball B and A move to separate directions. With respect to the original direction, ball A is in a motion with the angle of 60 and ball B is in a motion with the angle of 30. Now they ask us to find the final velocities of ball B and ball A after the collision. So it hints us that we have to find two unknowns. Okay, to find two unknowns, we need two equations. My initial plan is to apply linear momentum conservation in the original direction. So as there's no any external forces acting on that direction, it's in a smooth surface, we have to consider that. What can we do? We can equalize the initial momentum components to the final momentum components before and after the collision. Before the collision, what are the momentum components? M into 6 plus M into 0. After the collision, M into not VB dash, it's in a separate direction. We have to resolve the vector to take it in the correct direction. We are considering the original direction. To that direction, the influence of this velocity is VB dash cos 30. Okay, so M VB dash cos 30 is the momentum component to the original direction from B. From A, it's moving in a separate direction. The velocity is in a separate direction where it creates an angle of 60 with the initial. But vectors can be resolved. So if I take VA dash cos 60, that gives the velocity influence to the original direction. I can use that component to find the momentum in that direction, M VA dash cos 60. So the M VA dash cos 60, M VB dash cos 30 are the velocity momentum components to the initial direction after the collision. I have used them. Now what happened? M into 0, no use. Can simplify this M. And now 6 is equal to VB dash cos 30 root 3 over 2, VA dash cos 60 half. Okay. Now look at the board. What will be my next plan? Uta, you have to look at the board now. So what will be my next plan? I need two equations. So this is my next plan. I can notice if this ball B is moving initially in the considered direction, there was no any momentum in the perpendicular plane. I can consider the perpendicular plane to the initial plane. If the ball B is moving in the initial plane, if I consider the perpendicular plane, there's no any momentum. No momentum in the perpendicular plane. If there's no any momentum in the perpendicular plane, if the momentum conserves, that means if it doesn't change, what should happen? After the collision also, the momentum should be zero in the perpendicular plane. So here also you can't have a momentum. Now, initially, if the ball B is moving in the considered direction, there's no any influence to the perpendicular plane. Vectors do not affect the perpendicular plane. So momentum is a vector. It does not affect the perpendicular plane. So there's no any momentum in the perpendicular plane. This is at rest, so it will also not create any momentum in any kind of a direction. So there's no any momentum in the perpendicular plane to the initial plane. Now, after the collision also, there shouldn't be a momentum in the perpendicular plane. Why? The momentum conserves. So if the initial value is 0, final value should be 0. I'll write it like this. Initially, there is no any momentum. Initially, there is no any momentum in the perpendicular plane to the original direction. To the original direction. Initially, there's no any momentum. Initially, there's no any momentum in the perpendicular plane to the original direction. So after the collision, what happens? After the collision, there's a momentum there are momentums in the perpendicular plane. Why? If this is VB dash, angle here is 30, there's a vector component to this direction. VB dash sine 30. If this is VB dash and angle here is 30, there's a vector component to the perpendicular direction. VB dash sine 30. So there's a momentum. So after the collision, mass M into VB dash sine 30. There's a momentum in this direction. It should cancel out with the momentum in the other direction. So this direction, if it is VA dash cos 60, to this direction, the velocity is VA dash sine 60. VA dash sine 60. So the momentum to this direction is equal to mass into VA dash sine 60. Okay, they should cancel out each other. Why? Initially, there's no any momentum in the perpendicular plane. So if momentum conserves, there can't be a momentum in the perpendicular plane after the collision also. But after the collision, you can clearly see momentum components in both directions. If it is VB, this is VB dash sine 30. With M, the momentum will be M into VB dash sine 30 in this direction. If it is VA and 60 here, this is VA dash sine 60. If this is VA dash sine 60, with M, there's a momentum component to downward direction, M VA dash sine 60. But initially, in the perpendicular plane, you don't have momentums. If momentum conserves, you can't have momentums after the collision also in this direction. So what should happen? M VA dash VB dash sine 30 into M. The momentum in this direction should cancel out with the momentum in the opposite direction. M VA dash sine 60, M VA dash sine 60. Why? At the beginning, the ball B is only moving to the considered original direction. A is at rest. So there's no any momentum in the perpendicular direction. So after the collision also, there cannot be a momentum in the perpendicular direction. If so, VB dash sine 30 into M should cancel out with VA dash sine 60 into M. So after the collision, momentums in perpendicular plane should cancel. Okay. So when the VB is moving in this special direction, resolved component of the velocity to this direction is VB dash sine 30. Momentum is mVB dash sine 30. It should cancel with m. This is VA dash with angle 60. VA dash cos 60. So this direction VA dash sine 60. MVA dash sine 60 is the momentum component to this. These two should cancel out. Why? Initially, there was no any momentum in this perpendicular plane. Conservation means no change. So if there's no anything, now again, there should not be anything. So these two have to cancel. From there, I can create my second equation. M will cancel out. VB dash sine 30 means half is equal to VA dash sine 60 means root 3 over 2. 2 will cancel out. VB dash is equal to root 3 VA dash. This is my second equation. Now I have two equations. Equation X and equation Y. I can use these two equations to solve the problem. Okay. This is the 25th question. 27, 28, 29. Don't wait until I come. You have to go through all these. I will solve them one by one. Meantime, you have to pass me and move forward with these other questions. 27, 28, 29, 31, 33, 24, 23. I'll solve them one by one. Meantime, you have to pass me and continue with these questions. Okay. Now, I'm going to solve these two equations. 6 is equal to VB dash root 3 over 2. 6 is equal to VB dash root 3 over 2 plus VA dash into half. Multiplying all the terms by 2, 12 is equal to root 3 VB dash plus VA dash. From equation X, in equation X, I multiplied all the terms by 2. 12 is equal to root 3 VB dash plus VA dash. And from equation Y, I know VB dash equal to root 3 VA dash. 12 here. Here you have a root 3. From equation Y, I know VB dash equal to root 3 VA dash. VB dash is equal to root 3 VA dash plus VA dash. 12 is equal to root 3 VB dash. VB dash is substituted from the second equation. And here you have a VA dash. Root 3 into root 3, 3 VA dash plus there's another VA dash. 12 is equal to 4 VA dash. So VA dash is equal to 3. VA dash is equal to 3. If so, VB dash will be equal to root 3 into VA dash. That means VB dash is equal to root 3 into 3. So these are the velocities. Okay. Move to question number 27 then. An atomic nucleus. An atomic nucleus initially at rest decays into an electron moving with the momentum this much. A neutrino moving in the perpendicular direction with the momentum this much. Find the momentum and the direction of the recalling nucleus. Okay, that's a good one. පුතේ නියුක්ලියස් කියන්නේ සිංහලෙන් න්‍යෂ්ටියනේ. බහුවචනේ මොකක්ද? නියුක්ලියස්ද? මොකක්ද බහුවචනේ? නියුක්ලියයි. ඔව් නියුක්ලි. මේක මතක තියාගන්න. දැන් නියුක්ලියස්නේ සිංගියුලර් මේක. සිංගියුලර් එක න්‍යෂ්ටියක් පරමාණුක න්‍යෂ්ටියක් නියුක්ලියස්. බහුවචනේ. නියුක්ලියසස් නියුක්ලියයි. නියුක්ලි කියලා කියනවා. න්‍යෂ්ටි. ඔරිජිනල් නම් හිතන්නේ ඇමරිකන් ඉංග්‍රීසි වචනේ ඒක බලන්න. ඔයගොල්ලෝ බලන්න සර්ච් කරලා. හරි. කොමාරි නියුක්ලි කියලා ලියවෙන්නේ. නියුක්ලියයි එහෙම. නියුක්ලියසස් කියලා එකක් නැහැ එතකොට. Okay. So, let's move to question number 27. තනියෙන් වැඩ ටිකක් අරගෙන යන්න පන්ති වල සර්ලා ගණන් හැදුවට ළමයි දියුණු වෙන්නේ නැහැ. තනියෙන් තමන් වැඩ කරන්න ඕනේ. සෝ වැඩ කරගෙන යන්න ඕම ඉන්න ගමන්. මං එන්නම් පිටිපස්සෙන් එක එක හදමින්. Okay, I'm moving to question number 27. Now, there's a atomic nucleus, paramaणु का न्यष्टिक, initially at rest. Initially at rest. Okay? At rest. Then what happens? It decays into an electron moving in the momentum this much and neutrino moving in the perpendicular direction with the momentum. Okay. Initially, there's the atomic nucleus at rest. परमाणु का न्यष्टिक. Okay. Now what happens? It decays into an electron within hurry. Now, from this, an electron is emitted. Electron is emitted from this. An electron is emitted. Okay. This electron is having a momentum of PE. It's having a momentum of 9.22 into 10 to the power minus 21. And a neutrino moving in the perpendicular direction with the momentum is much. Okay. The atomic nucleus initially at rest decays into an electron moving the momentum this much and a neutrino moving in the perpendicular direction. Okay, there's a neutrino. So this is the electron, this is the neutrino. This is the electrode, this is the neutrino. Symbol of neutrino is something like this. Symbol of neutrino is something like this. With the momentum, what is the momentum of the neutrino? This is the symbol. This is the symbol. Okay. What is the momentum of the neutrino? 5.33 into 10 to the power minus 21. Okay. Find the momentum and direction of the recoiling nucleus. Due to these two emissions, what will happen to the remaining nucleus? I think it will move in the opposite direction to conserve the momentum. I will say find the momentum of the recoiling nucleus. I will say Pn, the momentum of the recoiling nucleus. Let's try to find it. It's a kind of a different question. It's okay. I'm going to explain it. I'm going to explain it. Okay. ටිකක් වෙනස් ප්‍රශ්නයක් නේද? හැන්ඩල් කරගන්න try එකක් දෙන්න බලන්න. මොකද්ද මේ වෙන්නේ? කොහොමද මේක හැන්ඩල් කරගන්න වෙන්නේ? Okay. Initially, if this nucleus is at rest, initial momentum is 0. If the nucleus is at rest in the beginning, initial momentum is 0. If so, final momentum should also become 0. Initially, it is at rest. Initially, the nucleus is at rest. So, its initial momentum is 0. Initial momentum is 0. So, definitely, final momentum is also 0. Okay, I'm not going to write it here because I need to mark these vector components. Final momentum is also 0. You have to notice that. Why? If the momentum conserves, that means it does not change. If so, if the beginning value is, if the initial value is 0, if it conserves, the final value should also become 0. So the final system is also having a 0 momentum. Okay. Now this is my plan. They say from this nucleus, an electron is emitted and a neutrino is emitted. And they are having perpendicular directions to each other. Electron is emitted in a certain direction and the neutrino is emitted perpendicular to it. Okay, and not only the electron and the neutrino, the remaining nucleus, it will also move. Observe the momentum. The remaining nucleus will have a momentum of P capital N. Neutrino is having a momentum of P simple N. Electron is having a momentum of P simple E. So electron is moving, the neutrino is moving, and the remaining nucleus will recoil. පිටිපස්සට තල්ලු වෙයි. Remaining nucleus will recoil. පිටිපස්සට තල්ලු වෙයි. තල්ලු වෙලා momentum එක 0 කරගනි. එහෙට මෙහෙට කැපිලා. Okay. Recoil means තල්ලු වෙනවා පිටිපස්සට. ගිය සතියේ කිව්වා recoil වෙනවා කියන්නේ පිටිපස්සට තල්ලු වෙනවා. Okay, electron is emitted, a neutrino is emitted, and to conserve the momentum, the remaining nucleus will recoil. පිටිපස්සට තල්ලු වෙයි. Okay. Now, I'm considering this direction. I am considering the direction. I'm considering the direction where this electron is moving. I'm considering the direction where this electron is moving. Okay, and my first consideration is the direction where the electron is moving. Neutrino is moving perpendicular to that direction, so it does not affect the direction where electron moves. The recoiling nucleus has a momentum of Pn. It's in a direction like this. I'm marking an angle alpha here. So, as my first attempt, I will consider the direction. Where electron moves. Okay, in that direction, momentum created by the electron should be cancelled out with the momentum created by the remaining nucleus. Why? Neutrino is perpendicular to that direction, so the perpendicular vectors will not affect. So the momentum created by the electron, 9.22 into 10 to the power minus 21, should cancel out with the momentum created by the recoiling nucleus on the opposite direction. Momentum created by the recoiling nucleus is Pn, and it creates an angle alpha with the direction of the electron. So it's alpha here, and so the momentum created by the electron, 9.22 into 10 to the power minus 21, should cancel out with Pn cos alpha. It should cancel out with Pn cos alpha. It should cancel out with Pn cos alpha. Okay, and then I'm considering secondly, I will consider the direction where neutrino moves. So, in the direction where the neutrino moves, it has its momentum P simple N. It should be cancelled with the momentum created by the recoiling nucleus opposite to it. Why? In this case, electron's motion is perpendicular to this new plane that we are considering. So, it will not affect this plane. So, this is my next plane I am considering. On this plane, with respect to this plane, electron's motion is perpendicular, so it will not affect. So the momentum created by the neutrino should cancel out with this is Pn cos alpha, this is Pn sin alpha. Island rank එහෙම ගන්න හිතන් ඉන්නවා නම් ඉතින් මේවා ගෙදවල වල ගිහිල්ලා ආයෙ හදන්න ඕනේ. නිකන් ඉලක්කම් සුළු කරලා විතරක් මදි. Pn sin alpha. Okay. So Pn sin alpha will cancel out with simple Pn. What is that? 5.33 into 10 to the power minus 21. Shall I explain it again? Shall I explain it again? Wait. Uday, everyone look at the board. Now, Uday, listen to me and look at the board. No hurry. Initially, there's an atomic nucleus, which is at rest. So as it is in a zero motion, it doesn't have a momentum. So initial momentum is zero. After that, due to a certain situation, it's called a atomic decay. What happens? From this nucleus, an electron, a neutrino, both of these subparticles are emitted. From this nucleus, an electron and a neutrino is emitted. So these emitted electron and neutrino have their own velocities and masses too. So what will happen? They will initiate new momentums, but there cannot be a resultant momentum. Why? At the beginning, there's no any momentum. So even the electron and neutrino is emitted and they have these momentums. Somehow these momentums should cancel out to conserve the momentum. Why? Because at the beginning, there was no any momentum. All the things were at rest. So somehow the recoiling nucleus, පස්සට තල්ලු වෙන nucleus එක මේ electron එකයි neutron එකයි momentums cancel out කරයි. No විකල්පයක් නැහැ. Why? Initially all the system is at rest, so no momentum. Conservation means no change. So final momentum should also become zero. To do that, the recoiling nucleus has to recoil. පස්සට velocity එකක් හදාගන්න වෙනවා to bring a new momentum to cancel out the momentums which were introduced by this electron and neutrino. In this case, this is how I'm going to solve it. I have drawn the picture correctly and I marked a certain direction where this electron is moving. I considered this electron is, the emitted electron is moving in this direction. So its momentum will be on this direction, PE 9.22 into 10 to the power minus 21. Its momentum will, electrons, new momentum will be on this direction as it is moving in this direction. As they say, the neutrino, another subatomic particle, it is moving in a direction perpendicular to the electron. So I have drawn it correctly. This is the motion of the electrode. Perpendicular to it, this is the motion of the neutrino. Okay, it's also having a momentum. Now, to cancel out these momentum components, how should this nucleus recoil? Let's see. I have to consider this very important fact. This electron and the neutrino are moving in perpendicular directions. Vectors in the perpendicular direction can't affect each other. So the momentum of the electron cannot be affected by the momentum of the neutrino. Why? They are perpendicular. So I will consider the direction where this electron is moving. So the momentum from the electron is in this direction. This direction is not affected by the perpendicular direction where the neutrino is moving. So I took this remaining nuclei recoils in a direction like this. Recoils in a direction like this. It creates an angle alpha with this line. It creates an angle alpha with this electron's motion, with this line. Okay, if this is PL, recoiling nuclei is having a momentum PL, and if this angle is alpha, what is this component? Pn cos alpha. So Pn cos alpha should cancel out with electrons' momentum in the opposite. So Pn cos alpha value wise, it's equal to electron momentum and they are in opposite direction, they will cancel out. So one problem is solved. Electron momentum is cancelled by the recoiling nucleus momentum and taken the component Pn cos alpha. Pn cos alpha will cancel out electrons momentum. When we consider that, we don't need to worry about neutrino. Why? It's in a perpendicular direction. They are not affected. And now I'll come to consider the momentum of the neutrino. It's in a direction like this. It's in a direction like this. So to cancel out that, I can't use the momentum of electron. Why? They are perpendicular. So I'll say like this. Neutrino's momentum, P simple N, will cancel out with P capital N sin alpha. Nucleus is having a momentum of Pn in a certain direction. If angle alpha is here, the component is Pn cos alpha to this side. We considered it. To other direction, it's Pn sin alpha. So what will happen? Pn sin alpha will be cancelled with the momentum of the neutrino. Then that problem is also solved. In both perpendicular direction, momentums are cancelled. Now the final momentum is also zero. So Pn sin alpha, recoiling nucleus is having a momentum Pn to a certain direction. Its component to this way, Pn sin alpha, will cancel out the momentum created by the neutrino. So this is also cancelled, and the momentum created by the electron also cancelled by from this new momentum component by the recoiling nucleus Pn, by the components Pn cos alpha and Pn sin alpha. Now our problem is solved. Initial momentum is zero because it was at rest. Now by this Pn, new momentum, when created, this nucleus is recoiling, it will cancel out the momentum components gained by the electron and neutrino. So final momentum is also zero. So this is the second equation. Now my first equation, beta. Okay. Now my first equation is I'm taking this one initially, Pn sin alpha. Pn sin alpha is equal to 5.33 into 10 to the power minus 21. Pn cos alpha, Pn cos alpha is equal to 9.22 into 10 to the power minus 21. I'm dividing them. I'm dividing the equations. Pn sin alpha is this much, Pn cos alpha is this much. I'm dividing one equation by the other. Pn will cancel out. Sin alpha over cos alpha. Sin alpha over cos alpha is equal to 5.33 over 9.22. Tan alpha. Tan alpha is equal to 533 over 922. I can find alpha. I can find alpha. Tan alpha is equal to 0.579. So alpha, you have to go to the logbook. I'll give you the answer by the calculator. You have to go to the logbook, but I'll give you the answer from the calculator. Okay. Wait. Calculator is in a different mode. It will take some time to reset. I have to look through the functions. I'll solve it through the logbook. Now the tan alpha is having a value 0.579. In the logbook, I'm going to tangents and I have to find where point 579 is 0.579 56 5735 5774 5774. Okay. Alpha is equal to 30 degrees 5774. Yeah. 30 degrees and 1 arc. Okay. Alpha is equal to, let's assume it's as value as a 30 degree. We'll consider this as 30. Yeah? Alpha is equal to 30 degrees and some arcs. I'm considering it as 30. Yeah? Alpha is equal to 30. If alpha is equal to 30, this is the alpha value. This is the alpha value. So look for the answer. In the answer sheet, what have they given in the tube? What is my answer? At an angle of 149 with the direction of the electron. Yes, that's correct. Now, electron is in this direction. Electron is moving in this direction. So if alpha is 30, from the other side with the electron, what is the angle? 150. Correct. 149 means approximately it's 150. Yeah, that's the answer. Now the atomic nucleus is recoiling at an angle of 150 from the direction of electron. Here alpha 30 means from the other side it's 150. Answer is correct. Then you have to find the Pn value also. What is Pn? Pn sin alpha is equal to 5.33 into 10 to the power minus 21. Pn sin alpha means 30. Sin 30 is equal to 5.33 into 10 to the power minus 21. Sin 30 is half. Sin 30 is half is equal to 5.33 into 10 to the power minus 21. So, Pn is equal to 2 into 5.33 10 to the power minus 21. Momentum of the recoiling nucleus 10.66 into 10 to the power 21 kg ms minus 1. Okay. Yeah, you got the answer. 10.66 means 1.06 10 to the power minus 20. You got I have received the exact answers also. දැන් ඉතින් මෙහෙමයි. මේ ගාන එකපාර හදාගන්න බැරි වුණා කියලා කවුරුත් මුකුත් කියන්නේ නැහැ. වෙන පන්තිවල මං හිතන්නේ මේ මට්ටමේ ගණන් හදන්නෙත් නැහැ. මම පුද්ගලිකව දන්නේ නැහැ. දන්න තරමින් නැහැ. එතකොට කලබලයක් නැහැ. දැන් බැරි වුණා කියලා දුක් වෙන්න ඒ වගේ චූටි චූටි ළමා වැඩ ඕනේ නැහැ. හැබැයි ගණ්ඩ දෙයක් තියෙනවා. ගෙදර ගිහිල්ලා ආයේ බලලා මේ දේ ගන්න ඕනේ. ලොකු රෑන්ක් එකකට එහෙම යන්න හිතන් ඉන්නවා නම් අපි මේ සාමාන්‍යයෙන් අපි කොහොමද කරන වැඩ. ඒක කරගන්න. Okay, I am going to explain this thing again. හරි පුතේ මේ අමතර විස්තරයක් වැඩ නවත්තන්න විනාඩියක්. මේ මම මේක ගාන අහගන්න වැඩනවත්ත. මම මේ ගාන හදා දින්න අතරේ ඔයාලට එන්න පුළුවන් වෙන ප්‍රශ්නයක්. ඔයාලා දන්න O level chemistry වලින් ඔයාලා දන්න O level chemistry වලින් නියුක්ලියස් එකේ ඉලෙක්ට්‍රෝන්ස් නැහැනේ. වටේට ඉලෙක්ට්‍රෝන්ස් තියෙන්නේ. කොහොමද නියුක්ලියස් එකෙන් ඉලෙක්ට්‍රෝන් එකක් වෙන්නේ? අවුල් දුකයිද? දුක් වෙන්න එපා එහෙම පුළුවන්. ඇයි ඒ? නිකන් අහගන්න විනාඩියක් විනාඩියක් අහගන්න ඔලුවට දාගන්න ඕනේ නිකන් අහලා තියාගන්න. ඔයාලා දන්න විදිහට යුනිවර්ස් එකේ බේසික් බිල්ඩින් බ්ලොක්ස් මොනවද ඔයාලා දන්න විදිහට? නියුට්‍රෝනුයි ප්‍රෝටෝනුයි ඉලෙක්ට්‍රෝනුයි. එතකොට නියුට්‍රෝනුයි ප්‍රෝටෝනුයි තියෙනවා නෂ්ටිය නියුක්ලියස් එක ඇතුලේ වටේට තියෙනවා ඉලෙක්ට්‍රෝන්ස්. ඒ අපි දැන් O level වලින් A level වලින් දන්න තරමනේ. මෙහෙමයි වෙන්නේ. යුනිවර්ස් එකේ බේසික් බිල්ඩින් බ්ලොක්ස් වෙන්නේ ඇටම්ස් වල ප්‍රෝටෝනුයි නියුට්‍රෝන්සුයි නෙමෙයි. තියෙනවා જાතියක් ක්වාක්ස් කියලා. ඔන්න ඔය ක්වාක්ස් වලින් තමයි ප්‍රෝටෝනුයි නියුට්‍රෝන්සුයි හැදිලා තියෙන්නේ. එතකොට ප්‍රෝටෝනුයි නියුට්‍රෝන්සුයි හැදිලා තියෙන්නේ ක්වාක්ස් වලින්නේ. සමහර වෙලාවට නියුක්ලියස් එක ඇතුලේ ප්‍රෝටෝන්ස් මාරු වෙනවා නියුට්‍රෝන්ස් වලට. නියුට්‍රෝන්ස් මාරු වෙනවා ප්‍රෝටෝන්ස් වලට. පුළුවන්. මොකද දෙගොල්ලන්ගෙම බේස් එක තියෙන්නේ ඊටත් වඩා පුංචි පාටිකල්ස් ක්වාක්ස් කියලා. ඔන්නෝම නියුක්ලියස් එක ඇතුලේ ප්‍රෝටෝන් එකක් නියුට්‍රෝන් වලට මාරු වෙද්දී නියුට්‍රෝන් එකක් ප්‍රෝටෝන් එකක් විදිහට අලුතෙන් වෙස් බැඳ ගනින්නේ. මේ මැද්දෙන් ඉලෙක්ට්‍රෝන්ස් කියන මෑස් එක හැදිලා එළියට පයින්නවා. ඒ නිසා මේ නියුක්ලියස් එකක් ඇතුලේ ඉලෙක්ට්‍රෝන් එකක් පයින් එක හරියම පොසිබල්. ඒකට කියනවා බීටා ඩිකේ කියලා. බීටා ඩිකේ කියලා කියනවා. ඒක උඩ තියෙන වැඩක්. ඒක ගණන් ගන්න එපා. ඒ නිසා නියුක්ලියස් එකකින් ඉලෙක්ට්‍රෝන එකක් පයින්න පුළුවන්. ඔය වටේට කරගෙන ඉලෙක්ට්‍රෝන නෙමෙයි. ඒක දැන් ගිහිල්ලා කෙමිස්ට්‍රි වලට දාන්න එපා. හරිද? ඒක නියුක්ලියර් ෆිසික්ස් වල තියෙන ලොකු වැඩක්. එතකොට නියුක්ලියස් එකකින් ඉලෙක්ට්‍රෝන එකක් පයින්න පුළුවන්. නැතුව වැරදිලා එහෙම දීලා නෙමෙයි. හරි දැන් බලා ගන්නකො. එතකොට තව එකක් නියුට්‍රිනෝ කියන්නේ මොනවද? නියුට්‍රිනෝ කියන්නේ තවත් චූටි පාටිකල් එකක්. හරිද? ඒ චූටි පාටිකලුත් මේ සිද්ධිවලදී නියුක්ලියස් එක ඇතුලෙන් පයින්න පුළුවන්. නිකන් ෆෝන් එක පාවිච්චි කර ඉන්න කාලෙද Google ගිහිල්ලා සර්ච් කර හැකි නියුට්‍රිනෝ කියලා ගහලා. ආයේ නිකන් වෙන මිලියන්ගේ ඒවා කියවන කල් නළුවන්ගේ ඒවා කියවනවා. Google ගිහිල්ලා සර්ච් කළ හැකි. හරි මේ how an electron is emitted from inside the atomic nucleus. පන්තියේ ගාණක් හම්බ වුණා මම සර්ච් කරලා බලනවා. සර්ච් කරලා බලන්න හැකියි. එතකොට අන්න බීටා ඩිකේ කියලා වැටිලා. හරි නියුට්‍රෝන ප්‍රෝටෝන මාරු වෙනවා ක්වාක්ස් කියන වචන දකියේ එකේ. එච්චර ලොකුවට ඕනේ නැති වෙයි. නමුත් ඒක තමයි කියුරියෝසිටි එකනේ. හරි. නිකන් පොඩ්ඩක් කියව ගත්තට කමක් නැහැ නේ. මොකද මේ විභාගෙට හින්දා නෙමෙයි. මේ අපි කියවන පල් හැලි වල හැටියට ඔය චුට්ටක් කියවුනහම මොකද අපේ අතේ? හරි. හරි. දැන් මෙන්න මම සිලබස් එක ඇතුලේ ඉඳලා අවශ්‍ය දේ ආයෙ එක්ස්ප්ලেইন කරන්න. හරි. වැටෙනවත්තන්න ආයෙ විනාඩියක් වැටෙනවත්තන්න මම ආයෙ එක්ස්ප්ලেইন කරන්න යන්නේ. පුතේ දැන් මෙතන මේ ඇටොමික් නියුක්ලියස් එක රෙස්ට් එකේනේ හිටියේ. ඒ නිසා මෙයාගේ මොමන්ටම් එක බිඳුවයි. එහෙනම් මේ ඇටොමික් නියුක්ලියස් එකෙන් එකපාරට ඉලෙක්ට්‍රෝන එකකුයි නියුට්‍රිනෝ එකකුයි විද්දා කියලා. එහෙමයි කියලා දැන් ඉනිෂියල් මොමන්ටම් එක 0 නම් තාමත් මොමන්ටම් 0 හදාගන්න එපා එහෙට මෙහෙට වෙලා. කන්සර්වේෂන් කියන්නේ 0 නම් 0 කියන එකනේ. වැලියු එකක් තිබ්බනම් ඒකම 0 නම් 0. හරි එහෙනම් මෙහෙම බලමු. මේ නියුක්ලියස් එකෙන් ඉලෙක්ට්‍රෝන එකක් විදිනවා මේ ඩිරෙක්ෂන් එකට. නියුට්‍රිනෝ එකක් විදිනවා මේ ඩිරෙක්ෂන් එකට. එතකොට ඒ දෙන්නගේ ඉලෙක්ට්‍රෝන එකයි නියුට්‍රිනෝ එකයි විදින්නේ පර්පෙන්ඩිකියුලර් ඩිරෙක්ෂන්ස් වල. ඒ නිසා ඉලෙක්ට්‍රෝන එකේ මොමන්ටම් එකට නියුට්‍රිනෝ එකේ මොමන්ටම් එකට එෆෙක්ට් කරන්නත් බෑ. නියුට්‍රිනෝ එකේ මොමන්ටම් එකට ඉලෙක්ට්‍රෝන එකට එෆෙක්ට් කරන්නත් බෑ. උන් දෙන්න පර්පෙන්ඩිකියුලර්. පර්පෙන්ඩිකියුලර් වෙක්ටර්ස්ලා බලපාන්නේ නැහැ. එහෙනම් මේ ඔක්කොම බර කරට ගන්න වෙන්නේ රිමේනින් නියුක්ලියස් එකට. රිමේනින් නියුක්ලියස් එකට හදා ගන්න වෙනවා මොමන්ටම් එකක්. එයාගේ එක රිසෝල්ව්ඩ් කම්පොනන්ට් එකකින් නියුට්‍රිනෝ එකේ මොමන්ටම් එක කපලා දානවා. එයාගේ අනිත් රිසෝල්ව්ඩ් කම්පොනන්ට් එකෙන් ඉලෙක්ට්‍රෝන එකේ මොමන්ටම් එක කපලා දානවා. එහෙම වුණොත් රිමේනින් රිකොයිලින් නියුක්ලියස් එකට තියෙන මොමන්ටම් එකක් pa. ඒකේ එක කෑල්ලකින් ඉලෙක්ට්‍රෝන එකේ මොමන්ටම් එක කැපෙනවා. ඒකේ අනිත් කෑල්ලෙන් නියුට්‍රෝන එකේ මොමන්ටම් එක කැපෙනවා. එතකොට ආයෙ ඔක්කොම කැපිලා බිඳුව එනවා. මොකද ඉලෙක්ට්‍රෝන එකට නියුට්‍රිනෝ එකටවත් නියුට්‍රිනෝ එකට ඉලෙක්ට්‍රෝන එකටවත් එෆෙක්ට් කරන්න බෑ. ඒ දෙන්න පර්පෙන්ඩිකියුලර්. එහෙනම් මම ගත්තා මෙහෙම. රිකොයිලින් නියුක්ලියස් එකට තියෙන මොමන්ටම් එකක් pn කියලා. මෙතන මම දාගත්ත ඉන්ට්‍රොඩියුස් කරා ඇන්ගල් එකක් ඇල්ෆා කියලා. එහෙනම් Pn cos alpha ගේ ඉලෙක්ට්‍රෝන එකේ මොමන්ටම් එක කැපෙනවා value wise equal opposite directions. Pn sin alpha ගේ නියුට්‍රිනෝ එකේ මොමන්ටම් එක කැපෙනවා value wise equal opposite directions. එතකොට මම Pn sin alpha equal කරා ඉලෙක්ට්‍රෝන එකේ නියුට්‍රිනෝ එකේ මොමන්ටම් එකට ඒක කැපෙන්න දෙපැත්තට. Pn cos alpha equal කළා ඉලෙක්ට්‍රෝන එකේ මොමන්ටම් එකට ඒක කැපෙන්න දෙපැත්තට. එහෙම අරන් ඉක්වේෂන්ස් දෙකක් අරන් ඒ දෙක බෙදුවා. එතකොට Pn cancel out වෙලා tan alpha මතු වුණා. tan alpha ගෙන් මම ඇන්ගල් එක හොයාගත්තා ආසන්නව 30යි ආල්. එතකොට මෙතන 30යි නම් එහා පැත්තෙන් 150යි උත්තරේ හරි. ඊට පස්සේ මම ඒ alpha ආදේශ කළා. සබ්ස්ටිටියුට් කළා Pn sin alpha ට ආපු උත්තරේට මොමන්ටම් එක හොයාගත්තා රිකෝලින් නියුක්ලියස් එකෙන්. හරි අයන් ඉස්සරහට. ගෙදර නිකන් අද හවසට ෆෝන් එකම ස්ක්‍රෝල් කරලා වෙනවා හරි බලනවා නම් නිකමට බලන්න how an electron is emitted from a atomic nucleus beta decay. වාප් කියන වචන එහෙම දකී එතකොට. නිකන් කමක් නෑ විද්‍යාවනේ. උනාම මොකද? Okay, question number 29. Question number 29. It's also a very interesting question. බලන්න. බැරිද වැරදිද? මේගොල්ලෝ මේ print කරන්න දෙනකොට copy paste එකේ තියාගෙන සමහර වචන දානවනේ ඒකයි වෙන්නේ. In 28 question, a car from mass 1000 in 28 question, a car of mass 1000 kg moving at 72 kilometers per hour collides with the stationary, that's wrong, collides with the 4000 kg lorry that comes from a perpendicular direction with the velocity of this much. Okay, in 28th question, a car of mass 1000 kg moving at 72 kilometers per hour collides with the 4000 kg lorry. In there, the word stationary should be, it's not there. Okay, it's a printing mistake. Okay, question number 28 is the next one. Then in question number 28, in the first line, the word stationary is not there. Then we will to take a print කරද්දී සමහර copy paste එකේ තියාගෙන ඉන්නවනේ වචන type කරන්න ලේසියට. ඒවා එහෙම මෙහෙම පැටිලා ඒවා වෙලා. බලනවා අපි බැලුවට සමහර වෙලාවට ඉතින් මිස් වෙනව නේද? ස්ටේෂනරි කියන වචනේ cancel වෙන්න ඕනේ. ඉතින් ගිය සතියේ පොඩි පොඩි ගණන් ටිකක් හදලා හොඳ තියරිටිකල් නොලෙජ් එකක් ගත්තා. දැන් ඉතින් අද තියෙන්නේ මේ වගේ වැඩක්. මේ යථාර්ථය අපි තේරුම් ගන්න ඕනේ ඉංග්‍රීසි මීඩියම් ක්ලාසස් වල වැඩි හරියක් වෙන්නේ හරි සිලබස් එක ගොඩාක් ඉක්මනට යනවා. එක තැනක චූටි දේවල් ටිකක් විතරයි ඉගෙනෙන්නේ. ෆිසික්ස් ක්ලාස් ගැන මම කියන්නේ. එතකොට සිලබස් එක හරි ඉස්සරහින් තියෙනවා. එතකොට ටර්ම් ටෙස්ට් එකේදී ටර්ම් ටෙස්ට් ඉස්කෝලේත් කරන්නේ ඕකමනේ. ඒ නිසා ටර්ම් ටෙස්ට් එකේදී මොකක් හරි ලකුණක් ගන්න පුළුවන්. හරිද? හැබැයි මතක තියාගන්න ෆයිනල් A level exam එකට යනකොට හැම ළමයෙක්ම සිලබස් කවර් කරලා ඉගෙනගෙන යන්නේ. එතකොට අර ටර්ම් ටෙස්ට් එකේ එන වාසිය කලින් මොනවා හරි දැනන් ඉඳලා ලියලා ලකුණක් එන වාසිය එන්නේ නැහැ. ඒ වෙනුවට එන්නේ සබ්ජෙක්ට් එක දන්න අමාරු ගණන් හදන්න පුළුවන් වැඩ කරපු අයගේ වාසිය එන්නේ. එතකොට කතාව අනිත් පැත්ත මාරු වෙනවා. නැත්තම් ඉංග්‍රීසි මීඩියම් වලට එන්නේ O level වලින් සාමාන්‍යයෙන් දක්ෂ ළමයිනේ. බය නැති වැඩක් කරගන්න පුළුවන් ළමයිනේ. ඒ වුණාට අපි ඇත්ත පිළිගත්තොත් රිසල්ට් වල වැඩි ප්‍රතිශතය තියෙන සිංහල මීඩියම්නේ. අපි විතරක් කියන කතාවක් අපි මේ කාටවත් එළිය කියන එකක් නෙමෙයි. අපි ඒක තේරුම් ගන්න ඕනනේ. ඒ මොකක්ද ඒ වෙන්නේ? ඒ අවශ්‍ය ස්ටෑන්ඩ් එක ගණන් හැදිලා නැති එකනේ. ඒක තේරුම් ගන්න ඕනේ. යථාර්ථය තේරුම් ගන්න බැරි වෙන්න බෑනේ. තේරුම් අරගෙන ඒ අවශ්‍ය මට්ටමට ගණන් හදන්න ඕනේ. පාර විභාගේ ලකුණක් අරගෙන කම්පෙයා වෙලා ඉස්කෝලෙත් එක්ක සතුටෙන් ඉන්නත් පුළුවන්. ඒ ඉතින් ඒකෙන් අවශ්‍ය දේ වෙන්නේ නැහැ. ඉතින් මේ මෙච්චර මේ ලංකාවේ සිංහල මීඩියම් පන්ති තියෙන ළමයි ලක්ෂයක් විතර ලියන. ඒ ළමයිගේ සිලබස් එක තියෙන තැන තිබුණාම ඇතිනේ සිලබස් එක. Okay, question number 28. Question number 28. A cow mass 1000 kg is moving at a velocity of 72 kilometers per hour. 72 kilometers per hour multiplied by 5 over 18, 20 meters per second. And there's another one, 54 kilometers per hour multiplied by 5 over 18, 15 meters per second. 15 meters per second. Okay. Question number 28. A cow mass 1000 kg. The cow mass 1000 kg is moving at a velocity of 20 meters per second. A cow of mass 1000 kg is moving at a velocity of 20 meters per second. Collides with the stationary for not there's you can't have this word stationary. Collides with the 4000 kg lorry that comes from a perpendicular direction with the initial velocity. So there's a lorry like this. This is the car. This is the lorry. It comes with the velocity of 15 meters per second and it's having a mass of 4000 kg. Now the lorry comes in this direction and the car is coming in this direction. At a junction, they collide with each other. They collide with each other. After the collision, both vehicles move together and comes up to rest after traveling 5 meters. Find the common velocity immediately after collision and the retarding force acting on the system after the collision. Okay, so this is the 5000 kg. 5000 kg මේ vehicles දෙක එකට ඇමිනිලා විනාශයක් 5000 kg mass එකක් හැදිලා. රෝදේ මේ අත යන්නේ පව් ඉතින්. මේක. So what will be the direction? දැන් මේ 1000 kg car එකයි 4000 kg lorry එකයි මිශ්‍ර වෙලා. ඇදිලා තියෙනවා මෙන්න වැදිලා අනේ එකට වැදිලා ඉතින් පව් මේකක් එකතු වෙලා. Okay? එතකොට දැන් මොකද්ද මේකේ වෙන්නේ කොහොමද ගාන හදන්න වෙන්නේ? ඔහෙට ගිහිල්ලා ඔක නතර වෙනවා. මේ කතාව දිග අර ගන්න වෙනවා. ෆිසික්ස් වලින් මේක දිහා බලලා දිග අර ගන්න වෙනවා. Okay, I'm going to explain this. Now, this is what happened. Initially, due to the momentum of the car, there's a momentum in this direction. So, after the collision, there's a momentum in this direction. P1. Initially, due to the motion of the lorry, there's a momentum in this direction. So, there's a final momentum in this direction too. P2. P2. Related to this momentum, there will be a velocity V1 in this direction. Related to this momentum, there will be a velocity V2 in this direction. When there are two perpendicular velocities, object will move in a direction like this with a velocity VR. First, we have to find this VR. Initially, due to the motion of the car, initially there's a momentum in the direction where the car is moving. So, after that, this vehicle combination should also have a momentum in that direction. Due to the motion of the lorry, there's an initial momentum in the direction where the lorry moves. So, as there's a momentum to be conserved, there's a final after the collision also, there's a momentum remaining in that direction where the lorry was moving. So, there's a velocity on that direction for the combination. There's a velocity for this direction for the combination. So these two perpendicular velocities will create a resultant velocity and the combination will move in a separate path like this. Car එක යන direction එකට යාගෙන් හම්බෙච්ච momentum එකක් තියෙනවා. Momentum එක conserve කරගන්න ගිහිල්ලා මේ vehicle combination එකටත් ඒ පැත්තට momentum එකක් හම්බ වෙයි. lorry එක ආපු direction එකේ momentum එකක් තියෙනවා. Momentum එක conserve කරගන්න ගිහිල්ලා ඒ vehicle combination එකටත් ඒ direction එකේ momentum එකක් හම්බ වෙනවා. මේ momentum එක බැඳිලා velocity එකක් තියෙනවා. මේ momentum එකත් එක්ක බැඳිලා velocity එකක් තියෙනවා. මේ velocities දෙක combine වෙලා resultant velocity එකක් හදයි ඒ පැත්තට combination එක තල්ලු වෙලා යයි. Okay. I'm applying momentum conservation to the direction. I'm applying momentum conservation to the initial direction of the car. I am applying momentum conservation to the initial direction of the car. I am applying momentum conservation to the initial direction of the car. 1000 into 20. Mass is 1000. Velocity is 20. When I am considering the initial direction of the car, initial direction of the lorry is perpendicular. So perpendicular vectors does not affect. When I am considering the initial direction of the car, initial direction of the lorry is perpendicular to that. So I need not to worry on that. So what is the initial momentum to the direction of the car? Only 1000 into 20. 4000 into 15 is perpendicular. It does not affect. So to the initial direction of the car, 1000 is to 20 is the initial momentum. Final momentum, vehicles are combined after the collision, 5000 into V1. 5000 into V1. What will happen? V1 is equal to 4 meters per second. Now, to conserve the momentum, which was inside the car at the beginning, this 5000 kg vehicle combination will receive 4 meters per second velocity in the direction where the car was moving. Why? To that direction, the lorry's direction is perpendicular, so it's not affecting. 1000 into 20, 5000 into V1. Okay? Then, secondly, momentum conservation to the momentum conservation to the direction, momentum conservation to the initial direction of the momentum conservation to the initial direction of the lorry. Momentum conservation to the initial direction of the lorry. 4000 into 50. Mass is 4000, velocity is 50. When we are considering the initial direction of the lorry, direction of the car is perpendicular to that. So it will not affect. It will not affect. 4000 into 15 is the only component at the beginning. 1000 into 20 is perpendicular to that. It doesn't affect. 4000 into 50, 5000 into V2 in this direction. 4000 into 50, 5000 into V2. Okay. So 60 over 5 is V2. Twelve meters per second. Okay, so V2 will be 12 meters per second. Now I have done this deal in perpendicular directions. So this vehicle combination is having a velocity of 12 to this direction, velocity of 4 to this direction. As those directions are also perpendicular, the resultant velocity will be 4 square plus 12 square into square root. So this direction it's 12, to this direction it's 4. So the resultant 4 square plus 12 square here. 144 root 160. Root 160. So what will be the answer? Twelve point 12.65 meters per second. 12.65 meters per second. Okay, then there's another thing they have asked. Find the common velocity immediately after the collision and the retarding force acting on the system after the collision. Now, after the collision, both vehicles move together and come to rest after traveling 5 meters. Okay, in this path, the vehicle combination will move for a 5-meter distance. In this path, the vehicle combination will move for a 5-meter distance. 5-meter distance. ඉන්නකො විසඳ ගන්න පොඩ්ඩක් අත හොද ගන්න වෙනවා ඉක්මනට. In this path, vehicle combination will move for 5 meters before it comes to rest. Before it comes to rest. Okay. So I'm going to solve that part separately. Now, the velocity is 12.65 meters per second immediately after the collision. Immediately after the collision, this 5000 kg combination is having a velocity of 12.65 meters per second. It will take 5 meters for this combination to come to rest. If so, okay, coming to rest means final velocity is 0. Through this path, I'm going to apply v square is equal to u square plus base. Finally, it will come to rest. Initially 12.65 square 2. Acceleration is a, s is 5. 0 is equal to, we got 12.65 through root 160. So it's 160 here plus 10a. Minus 160 is equal to 10a. A is equal to minus 60 meters per second. Meters per square second. Okay. If so, then applying F equals ma on this path, when the vehicle combination is moving forward, the acceleration is minus 60. Why is that? Due to the friction in the path. Due to the friction in the path, Fg. Minus Fg, due to the friction in the path, Fg is equal to mass m, 5000, acceleration minus 60. So Fg is equal to 80 into 10 to the power 3. Fg is equal to minus 80 into 10 to the power 3 newtons. Minus 80 into 10 to the power 3 newtons. Okay. Answers වල අවුලක් තියෙනවා අපි ආයෙ පාරක් බලමු. Answers වල අවුලක් තියෙනවා අපි ඒකත් ආයෙ පාරක් බලාගෙන full question එකම discuss කරගෙන යමු. මේක තමයි එතකොට තියෙන වැඩේ. හරි. आंसर्स टिक අපි ආයෙ බලමුනේ. Okay. Now I'm going to discuss this question again. Sorry, බලාගන්න. Now there's the car with a 1000 kg mass moving with the 20 meters per second velocity. So it's moving in this direction. To the initial direction of the car, the initial direction of the lorry is perpendicular. So perpendicular vectors does not affect. We don't need to consider the lorry when we are dealing with this initial momentum of the car. The lorry's velocity is perpendicular. Okay, I'm applying momentum conservation to the initial direction of the car. 1000 is 1000 into 20. After the collision, they become a combination 5000 into V1. Simplifying it, I received a velocity value of 4. And now I'm applying the linear momentum conservation to the initial direction of the lorry. When I'm considering the direction of the lorry, initial momentum of the car does not affect why it is perpendicular. So apply momentum conservation in the initial direction of the lorry, 4000 into 50, 5000 into V2. Okay. Then what happened? I received the velocity that this vehicle combination will achieve to the direction of the lorry, 12. This vehicle combination is having a velocity of 4 to the initial direction of the car. When there are two velocity components, what will happen? It will create a resultant velocity. What is that? As the components are perpendicular, 12 square plus 4 square into square root 160, 12.65 meters per second. Now, I'm drawing a separate picture. This 5000 kg vehicle combination is having a velocity of 12.65 meters per second, and it will move for 5 meters before stop. It will move 5 meters before stop. Applied v square is equal to u square plus 2a. At the end, velocity is 0. Here it's 12.65 square 2a/s. Okay, 0 is equal to 12.65 square means 160 according to the situation. 10a minus 160 10a, a is equal to minus 16. So after the collision, the vehicle combination has stopped after being traveling for 5 meters with a retardation of 60. Why is that? Due to a frictional force in the ground. Applied F equals ma to the direction of motion. Mass is 5000. Acceleration is minus 60. Force is equal to 80 into 10 to the power 3 newtons with a minus mark due to the retardation. Yes, the vehicle combination immediately after the collision received a velocity of this much. It became 0 after traveling 5 meters. Why? Due to the friction in the ground. And by the velocities, found the retardation value minus 16, acceleration is minus 60. Through that, by applying F equals ma, found the frictional force acted on this vehicle combination while it was moving 5 meters to be stopped immediately after the collision. Okay. Answers ටික මම ආයෙ ගෙදරදී check කරන්න. මම ඔය answers ටිකෙන් ඉස්සරහට යනවා. ඔයගොල්ලන්ට separate different answers ආවද? Okay. So question number 28. Now, question number 29. Question number 29. Question number 29. ඔයා මුහුද මැද්දේ ගඟකට ගිහිල්ලා බෝට්ටුවක් තියාගෙන බෝට්ටුවේ එක පැත්තකින් අනිත් පැත්තට ඇවිදගෙන යන්න බලන්න බෝට්ටුව පිටිපස්සට යනවා. ඔයා ගඟකට ගිහිල්ලා ගඟ මැද්දේදී ඔයාගේ බෝට්ටුව පහුරු ගාන මේක වැටෙනවා බිමට. දැන් ඔයාට යන්න විදිහක් නැහැ. ඔයා බෝට්ටුවේ එක මුල්ලකට ගිහිල්ලා අනිත් පැත්තට ඇවිදගෙන යන්න හිමීට බෝට්ටුව චුට්ටක් පස්සට යනවා. හැබැයි ඉතින් ඔයාට ඊට පස්සේ ආයේ අනිත් පැත්තට ඇවිදගෙන බෑ. එතකොට බෝට්ටුව ආයේ අනිත් පැත්තට යනවා. ගොඩ දාන්න බෑ. ඊට පස්සේ මුහුදට පැනලා ආයේ ඊනගෙන ඇවිල්ලා මේ පැත්තෙන් නැගලා ආයෙ පොඩ්ඩක් ඇවිදලා යනවා. ඒක බෝට්ටුව මේ පැත්තට යනවා. කතා කරමු. try එකක් දෙන්න. question number 29. කතා කරමු ඈ මොකද පොඩි නිකන් ඉනිෂියේටිව් එකක් දුන්න. Okay. Question number 29. Question number 29. A boat of length 6 meter and 40 kg is floating in a river. In a river, there's a boat. The boat of length 6 meter. Length of the boat is 6. One mage pan. The boat of length 6 and mass 40 kg is floating on a river. The length of 6 meter and mass is equal to 40 kg. ඉන්න ළමයි මම මේ පෑම් ප්‍රශ්නේ විසඳ ගන්නකෝ. ඔයගොල්ලෝ කරගෙන යන්න. මේ පෑම් ප්‍රශ්නේ මම විසඳ ගන්නකල් ඔයගොල්ලෝ කරගෙන යන්න. කොහොමගේ පෑම? පෑන් තියෙනවා 50ක් විතර. ඉන්න A boat of length 6 meters and mass 40 kg. අන්න දැන් හරියා. බෑන හරි. 40 kg is floating on a river. A man of mass 80 kg walks from one end to the other end. In one end there's a man. He is 80 kg in mass. Walk from one end to the other end with a constant speed. Let's say Vm. Let's say Vm. Find the distance moved by the boat related to the river. Find the distance moved by the boat related to the river. හරිනේ දැන් ඇති වෙනකල් වෙලාව හම්බුණා හදන්න මම මේ පෑන් හොය හොය ඉන්න අතරේ දැන් මම හදන්නයි යන්නේ වෙන වැඩ කරන්න බෑ දැන්. හරි? හා. මොකක්ද දැන් වෙන්නේ යන්නේ? හරි. අද වෙන වැඩ කරන එක නවත්තන්න ඕනේ. දැන් මොහොතකට හිතන්න වෙන වැඩ කරන්න එපා නේද? මෙන්න මේ මම ඉන්න ස්ටේජ් එකේ හරි නෑ ඒක මිනිස්සයාගෙන්ම ගමුකෝ. මේ මිනිස්සයා බෝට් එක දිගේ ඉස්සරහට ඇවිදගෙන යන්න මොකද්ද කරන්න ඕනේ? මේ මිනිස්සයා බෝට් එක දිගේ ඉස්සරහට ඇවිදලා යන්න මොකද්ද කරන්න ඕනේ? ඔයා ඇවිදිනවා කියලා මොකද්ද කරන්නේ? ඔයාගේ කකුල් වලින් පොළව පස්සට තල්ලු කරනවා නේද? ඔයා ඇවිදිද්දි මොකද්ද කරන්නේ? ඔයාගේ කකුල් වලින් පොළව පස්සට තල්ලු කරනවා. හැබැයි ඔයාගේ කකුල් වලින් පොළව පස්සට තල්ලු කරා කියලා පොළව ලොකුයි එයා ලොකු බොඩි එකක් එයාව මූව් වෙන්නේ නැහැ. හැබැයි දැන් මේ වතුර මේ දැන් ඉන්නේ වෝටර් සර්ෆේස් එකට. දැන් මොකද වෙන්නේ? ඔයා ඉස්සරහට ඇවිදන් යද්දි ඔයාගේ කකුල් වලින් බෝට් එකේ ෆ්ලෝ එක පස්සට තල්ලු වෙනවනේ. එතකොට නොතේරෙන්න කකුල් දෙකට යටින් බෝට් එක කොහෙද යන්නේ? පිටිපස්සට යනවා. නොතේරෙන්න කකුල් දෙකට යටින් බෝට් එක පිටිපස්සට යනවා. ඒතකොට ටික වෙලාවකින් බැලුවාම බෝට් එක මෙන්න මේ වගේ පොසිෂන් එකකට ඇවිත් තියෙනවා. ටික වෙලාවකින් බැලුවාම බෝට් එක මෙන්න මේ වගේ පොසිෂන් එකකට ඇවිත් තියෙනවා. ඇයි ඒ? අපි ඉස්සරහට ඇවිදන් යන්න ගැම්ම ගන්නේ අපේ කකුල් වලින් පොළව පස්සට තල්ලු වෙනවා. අපේ කකුල් වලින් පොළව පස්සට තල්ලු වෙනවා. එතකොට පොළවට මුකුත් වෙන්නේ නැහැ. පොළව මේ ලොකු බොඩි එකක්. නමුත් ඔයා මේ වෝටර් සර්ෆේස් එකක ඉන්නදී ෆ්‍රික්ෂන් එකක් නැති තරම්. එතකොට බෝට් එක ඒ තල්ලුවෙන් පස්සට යනවා. එතකොට බෝට් එක ඒ තල්ලුවෙන් පස්සට යනවා. එතකොට ඔයා හිතන්න බෝට් එක x දුරක් පස්සට ගිහින් තියෙනවා කියලා. බෝට් එක මේ පැත්තට ගිහින් තියෙනවා. බෝට් එකේ ඩිස්ටන්ස් එක මේ ලෙන්ත් එක නියතයක්. එතකොට මෙන්න මෙතන රිලේටිව්ලි මෙතනින් මොකද වෙලා තියෙන්නේ? බෝට් එක මේ තිබුණට වඩා මේ එජ් එක බෝට් එකේ මේ එජ් එක තිබුණට වඩා x වලින් මේ පැත්තට ඇවිල්ලා නම් මොකද වෙලා තියෙන්නේ රිලේටිව්ලි? මේ පැත්තත් x වලින් ඇවිල්ලා. එතකොට රූපේ දිහා හොඳට බලන්න. මෙතන ඉඳලා මෙතනට 6ක් තිබුණේ. එහෙනම් දැන් මේ ටික 6 රින x 6 x. හොඳට තේරුම් ගන්න මේ distance relationship එක. මේ බලන්න මේ. මෙතන ඉන්නවා from this end to the other end of the boat you have a 6 meter length to walk. But remember when you are walking to the right direction here, when you are walking forward, what will happen? From your legs you push the floor to the backward direction. To run in a forward direction, you have to push the floor in the backward direction. To run in a forward direction, you have to push the floor in a backward direction. When you are pushing the floor in a backward direction, what will happen? Here the boat is in a nearly smooth surface, in a water surface. The boat will move to the backward direction. Let's assume boat moved at length x to the backward direction. So other edge of the boat is also moving the same x to the backward direction. So when you are walking on the boat to reach the other edge, you don't need to walk for 6 meters. Why? That edge has moved a distance x to the backward direction due to the motion of the boat. So the length you have to walk is equal to 6 minus x in order to reach this position. Okay. Initial momentum of the boat is 0. Initial momentum of the system is 0. Initial momentum of the system is 0. If the initial momentum of the system is 0, the final momentum should also become 0. So the final momentum is also 0. So momentum created by the man in forward direction. Momentum by the man in the forward direction should cancel out with the momentum of the boat in the backward direction. Okay. So what is the momentum of the boat in the backward direction? Mass of the boat into velocity of the boat in this direction. That momentum should cancel out with the momentum of the man, mass of the man, velocity of the man in the forward direction. Method now, when you are running, you push the floor to the opposite direction to create the force to get the acceleration. When you are running, you have to push the floor into the backward direction in order to create the Newton's third law force and get the acceleration you need. When you run, you have to push the floor backward and there will be an equal and opposite force acting on you in the forward direction where it gives the acceleration for you to run. So, when you are running on a boat, what will happen? You have to push the boat flow to the backward direction and you will get the Newton's third law force and you will move to the front, to the forward direction. So this force that you created on the boat to the back direction will move the boat into the backward direction because it's in a water surface, no friction to stop the boat, so it will move backward. Initially, the momentum is zero, all the things are at rest. Now, to become the final momentum zero, the momentum created by the man in the forward direction should be cancelled with the momentum created with the boat in the other direction. Mass of the man is 80. Velocity of the man can be given by displacement of the man divided by time t. Mass of the boat is 40. Velocity of the boat can be given by displacement of the boat to the opposite direction over time t. What is the displacement of the boat to the opposite direction? I considered it as x. When you are running forward, your legs push the boat to the opposite direction. So boat has moved the direction x to the opposite side. So velocity of the boat is equal to x over t, distance over time. You are moving forward, and what is your velocity? You don't need to walk 6 meters in order to find the edge. Why? Boat is moving other side with the distance x. So to reach the edge, you have to walk 6 minus x as a length. When we consider the length, the distance you have to walk is equal to 6 minus x. Why? When the boat is moving other side with the distance x, the other edge will come closer to you from a distance x. Why? The complete length of the boat is a constant. If this boat is moving a distance x to the backward direction, what happens? This other edge will come closer to you from a distance x. So the distance that you have to walk to find that edge is equal to 6 minus x. 6 minus x over t. What will happen? T will cancel out the same time. 40x is equal to 480 minus 80x. 40x is equal to 480 minus 80x. 120x is equal to 480. X is equal to 4 meters. අපි බෝට් එකක් උඩ ඇවිදගෙන යනකොට අපි ඕනෙම තැනක් උඩ ඇවිදගෙන යනකොට අපි ඒ ඇවිදගෙන දුවගෙන යන්න ඒ ගැම්ම ගන්න පොළව පස්සට පුෂ් කරලා. ඉතින් ඒක පොළවට දැනෙන්නේ නැති වෙයි පොළව ලොකු බෝලයක්. නමුත් අපි බෝට් එකක ඇවිදිද්දි බෝට් එක තියෙන්නේ වෝටර් සර්ෆේස් එකක් උඩ. ඒක ස්මූත් කියලා හිතන්න පුළුවන්. ඒ නිසා අපි ඉස්සරහට ඇවිදින්න පොළව පස්සට පුෂ් කරද්දි අපිට නොතේරීම බෝට් එක පස්සට යයි අපි ඉස්සරහට යයි. බෝට් එක පස්සට යන හින්දා බෝට් එකේ අනිත් එජ් එකට යන්න අපිට 6 මීටර්ස්ම ඇවිදින්න ඕනේ නැහැ. බෝට් එක පස්සට යනවා නම් අපේ කකුල් වලට යටින් x 6 minus x ඇවිදිනකොට එජ් එක හම්බ වෙනවා. මොකද අපි ඉස්සරහට යන අතරේ බෝට් එක පස්සට ගිහිල්ලා. එහෙනම් අපි 6 minus x ඇවිදිනකොටම බෝට් එක x පස්සට ගියේ හින්දා අනිත් එජ් එක හම්බ වෙනවා. එහෙනම් අපේ velocity එක distance එක 6 minus x over t. අපේ momentum එක mass of the man into 6 minus x over t. බෝට් එක අනිත් පැත්තට යනවා. බෝට් එකේ මොමන්ටම් එක mass of the boat 40 into velocity of the boat. බෝට් එක අනිත් පැත්තට x ගියා. X distance over time, x over t is the velocity. So from this method, I can find the distance that the boat traveled into the opposite direction, x 4 meters. එහෙනම් මිනිස්සයා අනිත් එජ් එකට ඇවිදන් යන අතරේ බෝට් එක තිබ්බට වඩා 4 meters පස්සට ගිහින්. හරි. Okay. The next question. Question number 31. Question number 31. මගේ plan එක interval එක වෙනකල් මේ ගණන් ටික හදලා ඊට පස්සේ අලුත් lesson එකට යන්න. මගේ plan එක interval එක වෙනකල් momentum වලින් මේ ගණන් හදන් ගිහිල්ලා අලුත් lesson එකට යන්න interval එකෙන් පස්සේ යන්න. Okay. Question number 31. තව 20 minutes අපි යන්. ඊට පස්සේ අපි next lesson එකට යමු. Okay, what about question number 31? The rocket moving in outer space with speed of this much suddenly explodes into 3 fragments. 2 smaller fragments equal mass this much. Okay, okay. Try to solve it. Question number 31. මේ ගණන් ගෙදර ගිහිල්ලා ආය පාරක් බලන්න නේද? Shall I explain it again? Okay, I'll explain it again. ඊට පස්සේ මම ආයේ පොඩි period එකක් දෙන්නම් question number 31 වලට යන්න. හරි. මේ ගාන ආය පාරක් බලන්න අහගෙන ඉන්න. දැන් මම පොළවේ ඉස්සරහට දුවන්න ඕනේ නම් මම මෙහෙම ඉස්සරහට දුවනකොට ඉබේම මගේ කකුල් වලින් පොළව පස්සට තල්ලු කරනවා. ඇයි? මම ඉස්සරහට දුවන්න නම් මට ඉස්සරහට force එකක් ඕනේ. acceleration එක ගන්න. මම මොකද්ද කරන්නේ? මගේ කකුල් වලින් පොළව පස්සට තල්ලු කරනවා. එතකොට නිව්ටන්ස් third law වලින් මගේ body එක මත ඉස්සරහට force එකක් හැදෙනවා. මම පොළව පස්සට තල්ලු කරනවා action එක පොළවෙන් මගේ ඇඟ මත ඉස්සරහට force එකක් දෙනවා reaction එක. ඒකෙන් මට acceleration එක හම්බෙලා මං දුවන් යනවා. හොඳයි මං දුවන් යනවා සතුටුයි. පොළවට ওই වෙලාවේ මුකුත් හානියක් නැහැ. පොළව ලොකුයි. හැබැයි මම බෝට් එකක් උඩ ඉස්සරහට දිව්වොත් මේ බෝට් එක තියෙන්නේ මේ smooth nearly smooth water surface එකක් උඩ. එතකොට එයාගේදී මම බෝට් එක උඩ ඉස්සරහට දිව්වොත් මම බෝට් එකේ flow එක පිටිපස්සට තල්ලු කරලානේ ඉස්සරහට දුවන්න ගැම්ම හදාගන්නේ. මම ඉස්සරහට දුවන අතරේ අර මම බෝට් එකේ flow එක පිටිපස්සට තල්ලු කරන එක නිසා බෝට් එක smooth surface එකක් උඩ වතුර උඩ තියෙන හින්දා බෝට් එක පස්සට යනවා. ඒතර මම ඉස්සරහට යන අතරේ මගේ කකුල් දෙකට යටින් මට පෙනෙයි හිමින් බෝට් එක පස්සට තල්ලු වෙනවා. ඉතින් මම පටන් ගන්න මේ එජ් එකේ මම එහා පැත්තේ එජ් එකට දුවන අතරේදී මම හිතනවා බෝට් එක මගේ කකුල් දෙකට යටින් x පිටිපස්සට ගියා කියලා. එතකොට තේරුම් ගන්න ඕනේ බෝට් එකේ complete length එක නියතයක් constant එකක් 6 meters. ඉතින් මම ඉස්සරහට දුවන අතරේ බෝට් එක පිටිපස්සට ගියා නම් x වලින් බෝට් එකේ අර මම දුවන්න බලාපොරොත්තු වෙන එජ් එක එයත් මට x වලින් ලං වෙනවා. ඇයි? බෝට් එක මට යටින් x පිටිපස්සට යනවා. එහෙනම් මම දුවන්න හිතන් ඉන්නේ අනිත් එජ් එක මට x වලින් ලං වෙනවා. එහෙනම් මම 6 meters ම යන්න ඕනේ නැහැ. මොකද මට යටින් බෝට් එක අනිත් පැත්තට x ගිහිල්ලා හින්දා මම 6 minus x යනකොටම මට එජ් එක හම්බ වෙනවා. එහෙනම් මගේ velocity එක distance එක 6 minus x over time. mass එක 80යි. එහෙනම් මගේ momentum එක 80 into 6 minus x over t. Momentum is mass into velocity. Mass is 80. Velocity is distance over time. 6 minus x over t. එතකොට momentum conservation එකේ initially ඔක්කොමලා 0 momentum නේ හිටියේ. මමත් 0 boat එකත් 0 momentum හිටියේ at rest. දැන් මම දීපු momentum එක එහෙනම් boat එක අනිත් පැත්තට යන momentum එකට කැපෙන්න ඕනේ. කොහමද කැපිලා යන්න ඕනේ? මම දීපු මොමන්ටම් එක බෝට් එක අනිත් පැත්තට යන මොමන්ටම් එකට කැන්සල් අවුට් වෙන්න ඕනේ. එහෙනම් ඒකට බෝට් එකේ mass එක into velocity එක. mass එක 40, බෝට් එකේ velocity එක distance over time. බෝට් එක අනිත් පැත්තට move වුණේ x වලින් x over t. එතනින් මට x හොයාගන්න පුළුවන්. x is the distance that the boat travel to the opposite direction while I am moving forward. Okay. Then question number 31. Question number 31. Paper එක වෙලාවට ආවද? ආව නේද? Okay. So let's move to question number 31. A rocket moving in outer space with a speed of 6√2 meters per second. Mass of the rocket, it's same with a velocity, moving with a velocity 6√2 meters per second. What happens to this rocket? Suddenly explodes into 3 fragments, 2 smaller fragments. I'm going to say the initial mass is 3m. No, I'm saying I'm taking the complete mass is 5m. The complete mass is 5m. Complete mass of the rocket is 5m and its velocity is equal to 6√2 meters per second. Complete mass is 5m and the velocity is equal to 6√2 meters per second. Suddenly it explodes, and what happened? It will explode into 3 parts. What are the masses? 2 smaller parts, mass m and m. Same equal masses m and m. and the other part, two smaller fragments equal mass, and the third fragment has 3 times that mass of one small fragment. This part is having a mass of 3m. Hari, then hari gaya වැඩි. The total mass is 5m. The total mass is 5m. It explodes into 3 parts. Here the small masses are m each, and the larger mass having 3 times mass of a smaller one, 3m, altogether 5m. Okay. Now these smaller fragments move at 60 meters per second, making at an angle of 45 with the original direction of the rocket. So this is the original direction. Original direction. This one with the velocity v2 at an angle of 45 with the original direction. This one with the velocity v3 at an angle of 45 with the original direction. Okay. So, wait. It should be something like this. In the front fragment, this is M and the next is M. Wait, I have to redraw this thing. This is the original direction. This is the original direction. This part is moving with the velocity of v1. Let's say vx at an angle of 45. The other smaller fragment m to this direction at an angle of 45 vy. And the other part having a mass of 3m, altogether 5m is fulfilled to the opposite direction with the vz. Now the diagram will match the conditions they say. So this is the situation. Initially, rocket is moving to a certain direction with a velocity of 6√2 meters per second, and I have taken the complete mass as 5m. Now it has exploded into 3 parts. There are 2 smaller fragments with same mass, m and m, and the larger fragment is having the mass 3 times the smaller one, 3m. Altogether 3m plus m plus m, 5m. Okay, the final initial mass is also 5m. Now the mass is matched correctly. Initially 5m, 3 fragments, m, m and 3m. Addition is 5m again. Okay. 2 smaller fragments move with velocities vx and vy at an angles of 45 with the original direction. And the larger fragment is moving to the opposite direction of the initial direction with the velocity vz. And now the drawing is correct. Applying linear momentum conservation in the original direction, applying LMC in the original direction. Applying LMC in the original direction. 5m into 6√2. 5m into 6√2. M Vx cos 45. The other M Vy cos 45 plus 3m into minus Vz. 3m into minus Vz. 5m into 6 root 2, 5m into 6 root 2, m vx cos 45, m vy cos 45, 3m into minus vz. Applying the linear momentum conservation in the original direction, initial momentum 5m into 6 root 2, mass 5m, velocity 6 root 2 is equal to the final momentum components m vx cos 45 to this direction. The next term vy cos 45. And to that direction, 3m into Ez, but Vz is minus, it's moving in the opposite direction. Okay, m will cancel out. 30 root 2 Vx cos 45, 1 over root 2 plus Vy cos 45, 1 over root 2 plus 3m into minus Vz. Why minus Vz? They say the larger fragment moves in the opposite direction with respect to the initial direction. So when we are applying LMC to the initial direction, as this 3m part is moving to the opposite direction, velocity is minus 3m into minus Vz. That means 3 Vz. 3 Vz. Okay. Multiplying all the parts by root 2. 30 root 2 multiplied by root 2. Vx plus Vy minus 3 root 2 Vz. 30 root 2 multiplied by root 2. 30 root 2 into root 2. Vx, Vy minus 3 root 2 Vz. Okay. Applying LMC to the perpendicular direction with respect to the initial. Applying LMC to the perpendicular direction. Applying LMC to the perpendicular direction of the initial direction. Applying LMC to the perpendicular direction of the initial direction. Initially, momentum is 0 in this new direction. Initially, the momentum is 0 in this new direction. In this new direction, momentum is 0. In this new direction, momentum is 0. Initially, it was moving in the original direction. So, with respect to that direction, the perpendicular direction does not have a momentum. So, after the explosion also, momentum in the perpendicular direction should cancel out. Vz is in the same opposite to the initial direction. It does not affect the perpendicular direction. Vx sine 45, this one, this momentum component. M Vx sine 45. M Vx sine 45 should cancel out with the other momentum component. M Vy sine 45. M Vy sine 45. M Vy sine 45. M Vx sine 45 should cancel out. M will cancel out. Vx over root 2 is equal to Vy over root 2. Root 2 cancels. Vx is equal to Vy. Second equation. This is the first equation. I'm going to explain the situation up to this point and going to solve for the answer. and we'll give you the interval. ටික වෙලාවකින් මම මේක ආයෙ explain කරනවා. explain කරලා answer කරන් interval එක දෙනවා. පුතේ මොකද ඔය කරන්නේ? ළමයි මොකක්ද කුටි පියස් හැරලා කරන්නේ? ඉස්සරහට හැරෙමු. හරි. හරි. මම ආයෙ මේක explain කරන්න යන්නේ. දැන් මේ rocket එකක් තියෙනවා. යාගේ mass එකට මම 5m කියලා දාගත්තා. මොකද මම ගාන එකපාරක් සම්පූර්ණයෙන් කියෙව්වා. එතකොට මට අහු වුණා මේකේ පොඩි equal පොඩි masses එකක් තියෙනවා equal mm. අනික් mass එකක් අර පොඩි mass එකක් වගේ 3 times 3m. එතකොට මොකද වෙන්නේ? 3m plus m ඔක්කොම 5m වෙනවනේ. මම initially 5m දාගත්තා. එතකොට හොඳට ratios හැදෙනවා. Okay. 5m is the mass, velocity is 6√2. It's moving in a certain direction. Suddenly this rocket explodes and it will create 3 fragments, m, and 3m. One fragment move with the velocity vx at an angle of 45 to the initial. Other fragment, the same equal mass fragment, mass m, is moving to another direction, creating an angle of 45 and velocity is vy. The remaining larger fragment, mass 3m fragment, is moving to the opposite direction with the velocity vz. Now, there are many unknowns. So you can't find this all things from a single equation. You have to use many equations. So thought of applying linear momentum conservation in the initial direction, 5m into 6√2 is the initial momentum in the original direction. What is the momentum after the explosion in the original direction? If this is Vx cos 45 is the velocity in the initial direction. M, Vx cos 45. If this is Vy, what is the velocity in the initial direction? Vy cos 45. M, Vy cos 45 is the momentum component. And 3m into Vz is not the answer. 3m into minus Vz. Why? The mass 3m is moving to the opposite direction. So you have to hint that from the minus mark. When you consider the initial direction, the opposite direction will be denoted by this minus mark. So 3m into minus Vz is the momentum component of that part. Initial momentum 5m into 6√2 is equal to m Vx cos 45, other m Vy cos 45, 3m minus Vz. Okay. M will cancel out 5 into 6, 30√2 Vx 1 over root 2 cos 45 plus Vy cos 45 1 over root 2 minus 3 Vz multiplied by root 2. Then I got the answer 30√2 into root 2 Vx plus Vy minus 3√2 Vz. 30√2 into root 2 means 60. Root 2 into root 2 is 2. 2 into 30 is 60. 60 60 60 is equal to Vx plus Vy minus 3√2 Vz. 60 is equal to Vx plus Vy minus 3 root 2 Vz. Okay. First equation. Second equation, Vx is equal to Vy. Vx is equal to Vy. Why? The velocity momentum should cancel in the perpendicular direction. Correct? Here it is M. So in the perpendicular direction, M Vx sine 45. In the other direction, M Vy sine 45. Initial direction is this one. Initially, you don't have a momentum in the perpendicular direction to the initial. You don't have a momentum in the perpendicular direction to the initial. Okay. So here, in the final case, after the explosion, momentums in the perpendicular plane should cancel out. Mvx sine 45 should cancel out with Mvy sine 45. From there, you can get the condition that Vx is equal to Vy. Then what will happen? Two smaller fragments, equal mass, move with 60 meters per second velocity. Vx is equal to Vy. So here 60 Vx, Vy is also equal to Vx minus 3 root 2 Vz. Okay. 60 is equal to Vx, Vy is also equal to Vx minus 3 root 2 Vz. And they have given this Vx as 60. They have given, it's a data, it's given Vx as 60. Here, two smaller fragments equal of mass move at 60 meters per second at an angle of 45. So Vx is given as 60, Vy also 60, minus 3 root 2 Vz. Okay. So 3 root 2 Vz. 3 root 2 Vz is equal to 120 minus 60. 120 minus 60. 3 root 2 Vz is equal to 60 again. Vz is equal to 60 over 3 root 2 meters per second. So Vz is equal to, okay, 60 over 3 root 2. Here 60 divided by 3 is 20. 20 over root 2. Vz is equal to 20 over root 2. You have to multiply it by root 2. 20 over root 2. I am multiplying both sides by root 2. 20 over root 2 and multiplying both sides by root 2. Okay. Then 20 over root 2 and multiplying both sides by root 2. Then what will happen? This root 2 and root 2 become 2. 20 over 2 and here you have a root 2. So it cancels 10 root 2. Velocity of the larger fragment is equal to 10 root 2. Velocity of the larger fragment is equal to 10 root 2. Okay. Now I have completed all the methods that you can get for your exam. Okay. There are many other questions with the same types that you can practice at home. Okay. We are moving to next lesson after the interval. Talk, center of gravity and equilibrium. Mavindu sound harapute. Okay, I'm going to start the next lesson. Let's write the topic torque, center of gravity, and equilibrium. Torque, center of gravity, and equilibrium. Next topic, torque, center of gravity, and equilibrium. Torque, center of gravity, and equilibrium. Torque, center of gravity, and equilibrium. Now, here in this lesson, torque, center of gravity, and equilibrium, what we're going to learn is something like this. We are going to learn how the objects keep their balance while the forces are acting on them. Okay. So from this lesson, torque, center of gravity, and equilibrium, what is our aim? We are going to learn how the objects keep their balance while there are many forces acting on them. Okay. Write the first sentence. Under this lesson, we will learn how the objects. Under this lesson, we will learn how the objects maintain their balance. How the objects maintain their balance. Within brackets, keep the equilibrium. Within brackets, keep the equilibrium. Within brackets, keep the equilibrium. While the forces are acting on them. While the forces are acting on them. Okay. Now, here, there's a knife edge like this. On this knife edge, a meter ruler is kept. On this knife edge, a meter ruler is kept. Okay? And now this meter ruler is in a balanced situation. It's in the equilibrium. It's balanced. So you have to mark the weight of the meter ruler. And from this knife edge, there will be a reaction. But what has happened? Still, the object is in an equilibrium position. So in this lesson, we are going to learn how this equilibrium is maintained, by how the object keep their balance while the forces are acting on them. Okay, this is the final aim. The final aim is to understand how the objects maintain their equilibrium, keep their balance while the forces are acting on them. To do that, we have to come one by one with these special theories. Okay. The first subtopic, torque. Torque, torque, or the normal name, moment of force. Torque, or the moment of force. Okay. So the first subtopic, torque, or the moment of force. Torque, or the moment of force. Now, what is torque or the moment of force? Now, to show you this moment of force, I'll take the meter ruler. I'll meter ruler. Wait. I'll bring the meter ruler. Okay. Now, here, so I'll explain the things that I have given you again. The main topic is torque, set of gravity and equilibrium. Under this lesson, we will learn how the objects will maintain their equilibrium, keep their balance while the forces are acting on them. To understand this topic, we have to go with these subtopics one by one. First subtopic, torque or the moment of force. Now, what do you mean by the moment of force? Now, I have taken a meter ruler and this meter ruler is pivoted. Pivoted from this point. මෙතනින් high කරලා තියෙන්නේ කැරකෙන්න පුළුවන්. Pivoted. Pivoted කියන්නේ මොකද්ද? කැරකෙන්න පුළුවන් විදිහට high කරලා තියෙන්නේ. have I have this meter ruler in my hand. Let's assume that this meter ruler is pivoted from this point. What is pivoted? කැරකෙන්න පුළුවන් විදිහට high කරලා තියෙන්නේ. It's fixed in a manner where it can rotate. Okay, so this is pivoted. Now on this meter ruler, what happens if I apply a force like this? If I apply a force like this, what will happen to the meter ruler? If I apply a force like this, what will happen to the meter ruler? It will rotate. It will rotate like this. If I apply a force to the meter ruler, it will rotate like this. This is pivoted from here. It's fixed in a manner where it can rotate. It's fixed from this edge, but it is possible to rotate. That is pivoted. When it is pivoted from this edge, I'm applying a force like this, it will rotate. Okay. So, when it is rotating, this rotating power or the rotation is given by the physical quantity torque or the momentum. This ability to rotate. This ability to rotate when a force is applied on a certain object, when it's pivoted from a certain point, this ability to rotate, this rotation is given by the physical quantity torque or the moment. It's equal to the force applied into the perpendicular distance from the pivoted point to the force. It's equal to, the torque is equal to force applied into the perpendicular distance from the force to the pivoted point. This physical quantity torque or the moment will represent the ability to rotate. Why? If we are considering the equilibrium, of object, we have to cancel out the ability to rotate. One day when we are learning this full topic, equilibrium. In the equilibrium, we consider about the objects, how they keep their equilibrium without any motion, how they keep their balance. Sometimes they might rotate. How to stop that? Then you have to stop the balance, stop the rotation in order to keep the equilibrium, to keep the balance. So we have to know how objects rotate. Later, we have to understand how the objects keep their equilibrium, keep their balance. Sometimes objects are tend to rotate. But if you need to keep the equilibrium, keep the balance, you have to stop that rotation. In order to understand these kind of things, first you have to know how the objects are rotated. Then only you can understand how to stop the rotation. So the rotation is denoted by this torque or the moment. when an object is pivoted from a certain point, if you apply a force, it will say this meter ruler is the object, it is pivoted from this end. When you apply the force, it will rotate like this. This rotation in physics, it is denoted by this torque or the moment of force. It's given by force into the perpendicular distance from pivoted point. Okay. What will be the SI units? Newton into meter. Okay. Let's fill this first. Torque or the moment of force. This meter ruler is pivoted from this point. It has a distance d, a perpendicular distance to the force applied. In such a situation, the moment or the torque is given by force into the distance value. Measured by Newton meters, it measures the ability to rotate. The torque, it measures the ability to rotate. Main lesson is torque, center of gravity and equilibrium. In this lesson, we are going to understand how the objects keep their balance while the forces are acting on them. Sometimes when the forces are acting on objects, these objects try to rotate. So if we are going to keep the equilibrium, we have to stop this rotation. Okay. To understand these kind of things, first we have to understand how this rotation happens. So it's this first part, torque, moment of force. The rotation is rotation is occurred due to a moment of force or torque. I have taken a meter ruler, pivoted from its left edge, and I have applied the force F from a perpendicular distance d. The ability to rotate is measured by the moment, torque. It's equal to force into distance. And the SI unit will be Newton meters. Now, when we measure this ability to rotate or the moment, we have to consider very special point. What is that? If a force is applied from this side, keeping a distance d, this meter ruler will rotate in this direction, in this way. But in the other hand, the same meter ruler pivoted from the same point, the force applied from the same distance, but in the opposite side. What will happen? Now it will rotate in the other way. So this kind of a rotation is known as a clockwise rotation. It's a clockwise. And this kind of a rotation by a force like this meter ruler will be rotated in the other side. This is a anti-clockwise. This is the anti-clockwise rotation. So you have to be very careful about the clockwise or the anti-clockwise. That means you have to understand what is the method that this thing going to rotate. In this case, pivoted from here, force applied like this. It will rotate like this, a clockwise rotation. In this case, force is applied like this with a distance d, and it will rotate in the other side, anti-clockwise rotation. Okay. Then let's make this as the Roman number 2 and this as the Roman number 1. You have to draw this diagram also. It will be Roman number 2. The clockwise and anti-clockwise rotations. When the force is applied, keeping a certain distance d to the pivoted point, there will be a rotation created, a moment of force, Fd. And this rotation can be happened in a clockwise manner or anti-clockwise manner. Sometimes you don't need to write all this clockwise rotation. Sometimes it is denoted by this symbol, arrow like this. It will give the direction of this method of rotation, anti-clockwise, arrow like this. Okay. Now go to the first question in your tube. Go to the first question in your tube. For each of the force shown, find the moment of the force about point O. State whether the moment is clockwise or anti-clockwise. Okay. Go to the first question, and you have to draw these diagrams one by one and find the moment or the torque related to these diagrams. There you have to state whether the motion occurred or the rotation occurred will be a clockwise or anti-clockwise one. We are going to understand the lesson, do the lesson talk, center of gravity and equilibrium. Our final aim is to understand how the object keep their balance or to keep the equilibrium while the forces are acting on them. To do that, first we understand the moment or the moment of force or the torque. Why? The moment stands for the ability to rotate. In equilibrium, we have to stop that, the rotation. So let's go to find the ability to rotate. The ability to rotate is understood by the physical quantity torque or the moment of force. It is given by force into the perpendicular distance to the pivotal point. And it has two main categories, clockwise moments and anti-clockwise moments. Now, find the moments in the diagrams I have given to you and state whether they are clockwise or anti-clockwise. First question, first part. Point O is something like somewhere here, and there's a 3-meter perpendicular distance to the force that is equal to a 10 Newton value. So the moment force into the perpendicular distance, force is 10, perpendicular distance 3, 30 Newton meters. Moment is equal to 30 Newton meters, and assume my meter ruler example. This is the meter ruler. They will not show it to you. This is the meter ruler, or this is the object. They will not show it to you. And you are pushing it like this. It is pivoted from this point. When you push it like this, what happens? It will rotate like this. So what is this moment? It's an anti-clockwise moment. It's an anti-clockwise moment. විරුද්ධ පැත්තට. perpendicular distance එක දිගේ හිතේ මම අර තියපු මීටර උල තියන්නේ. perpendicular distance එක දිගේ හිතේ මම තියපු මීටර උල හිතෙන් තියන්න. ඒගොල්ලෝ ඇඳලා පෙන්නන එකක් නැහැ. හිතෙන් තියන්න. තියලා තල්ලුවක් දාලා බලන්න කැරකෙන්නේ කොහොමද කියලා. Second one, this is the pivoted point O, a perpendicular length 2 meter value, the 20 Newton force. So the moment is equal to the ability to rotation, F into D, 20 into 2, 40 Newton meters, and they will not show the object. Okay, let's assume it's a meter ruler. Let's say it's a meter ruler pivoted from O, and it lies like this. You are pushing it like this. What will happen? It will rotate like this. And this is a clockwise moment. It's rotating clockwise. It's a clockwise moment. This is a 5 meter length. And this is a 5 Newton force. This is 4 meters. Okay. Here I need to show you a special point. What is the moment here? Torque is equal to, or the moment is equal to force into perpendicular distance. So what is the perpendicular distance to the force 5 Newton value? Is 3 or is 4 or what? You have to find the perpendicular distance to the force. You have to find the perpendicular distance to the force. Puta, here, this 5 meter value, it's not a perpendicular distance. It's not a perpendicular distance. Here, it's not a perpendicular distance to say. It's not a perpendicular distance. Or this is also not a perpendicular distance. If you can't, if a perpendicular distance is not possible, if a perpendicular distance is not possible for the force, first you have to draw the line of action of the force. Force line of action. You have to draw the line of action of the force. And you have to recreate a perpendicular distance to that. You have to recreate a perpendicular distance to that. That's how you have to deal here. Later, when we continue the lesson, you will understand why. When we continue the lesson, you will understand the physical meaning of this. But for the moment, I will tell you the thing. And with the lesson, with the growth of the lesson, you will understand why we did this. Puta, if you can't find the perpendicular distance to the force, let's continue it. Let's draw the line of action of the force. And for that line of action, you have to redraw a perpendicular distance. From Pythagoras theorem, if it is 90 here, 5 here, what will be this distance? D is equal D square plus 4 square is equal to the 5 square. From Pythagoras theorem, D square plus 4 square, here 90 is equal to 5 square. D square plus 16 is equal to 25. D square is equal to 9. D is equal to 3. So here the perpendicular distance is 3. Perpendicular distance 3 with the line of action, the continued force is equal to 5. So the momentum is equal to F into perpendicular distance 5 into 3 15 Newton meters. And through this perpendicular distance, keep your hypothetical meter ruler. ඒගොල්ලෝ object එකක් දෙන එකක් නැහැ. ඔයා perpendicular distance එක දිගේ hypothetical object එකක් තියාගන්න. කියලා තල්ලු කරලා බලන්න. This is the way. It's a anti-clockwise torque or moment. So this is what you have to load. Well, okay, give me a small star mark there. Then I will give you the time to finish this. Fill this. Okay, give me a small star mark there. If we can't find the perpendicular distance to the drawn force, if we can't find the perpendicular distance to the drawn force, if we can't find the perpendicular distance to the drawn force, if we can't find the perpendicular distance to the drawn force, continue its line of action. Continue දික් කරන්න එයාගේ ක්‍රියා රේඛාව. Continue its line of action. Continue its line of action and take the perpendicular distance. Take the perpendicular distance to that and take the perpendicular distance to that from point O. From point O. From point O. Okay. So I continued the line of action and drew a new perpendicular line to that line of action. And from Pythagoras theorem, I came to know that this perpendicular is equal to 3 meter length. Okay, so the torque will be 5 into 3, 15 Newton meters, and I kept my hypothetical meter ruler. Through the perpendicular I have drawn and applied the force and checked the method. It was an anti-clockwise method that this rotation going to occur. Okay. For this anti-clockwise and clockwise things, you can't say the direction. I'll explain them one by one. Okay. සිංහලෙන් නම් කියන්නේ පුතේ ඒකට භ්‍රමණයේ අත කැරකෙන අත කියන දිශාවනේ මේ අත කියන. ඉංග්‍රීසියෙන් කියන්නේ ඉතින් එකක් anti clockwise අනික clockwise කියන. Direction එක කියලා කියන්නේ නැහැ. The moment is clockwise. The moment is anti-clockwise. Direction of the moment? No. Direction of the moment කියලා කියන්නේ නැහැ. I'll explain the direction later. This is a clockwise moment. This is a anti-clockwise moment. That's how we say that. Not the direction. No, direction word is wrong. I'll explain why. This is a anti-clockwise moment. This will cause a anti-clockwise rotation to the hypothetical object kept through the perpendicular. This will cause a clockwise rotation to the hypothetical object kept on the perpendicular. It's a clockwise moment. This will cause a anti-clockwise rotation to the hypothetical object kept on the perpendicular. So it's an anti-clockwise moment. That's all. Not the direction. There's a different meaning for the direction. I'll explain it one by one. Okay. Question number 4. Question number. This is a 10 Newton force. There's a perpendicular length of 1 meter to the considered point O. Moment over point O is equal to force 10, distance 1, 10 Newton meters. Keep an hypothetical object along the perpendicular and apply this force. What you will see, that object will move in a anti-clockwise manner. මේ ඔරලෝසුවේ කටු කරගෙන පැත්ත නෙමෙයි. ඔරලෝසුවේ කටු යන්නේ මෙහෙමනේ. මේ ඔරලෝසුවේ කටු කරගෙන පැත්ත නෙමෙයි, anti-clockwise. So it's a anti-clockwise moment. 5. Here there's a 20 Newton force and a 4 meter perpendicular length is given with respect to point O. Moment over point O, moment about point O is equal to force 20, perpendicular distance 4. 80 Newton meters. Keep an hypothetical object along the perpendicular and apply this force and check the manner of the moment. It's a clockwise manner. It's a clockwise manner. Now write another small sentence. Write another small sentence somewhere with a star mark. With a star mark. Keep a hypothetical object. Keep a hypothetical object along the perpendicular. 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 And apply the given force on it. Apply the given force on it. And apply the given force on it. 2. Find whether the moment is clockwise or anti-clockwise. To find whether the moment is clockwise or anti-clockwise. Keep a hypothetical object along the perpendicular and apply the given force on it. Then you will see the method of rotation in order to find the moment, whether it's clockwise or anti-clockwise. Here, it's a clockwise moment. Why? If this is the hypothetical object, when a force like this is applied, it will rotate like this. It's pivoted from point B, it will rotate like this. It's a clockwise moment. Okay, part 6. Now, there's a force 20 Newton value, and this force is moving over considered point O. So what is the moment about point O? It is equal to force to the perpendicular distance from the point you consider. Force is 20. What is perpendicular distance? It's 0. If the force line of action, the force or the line of action is passing the considered point, then you don't perpendicular distance to that point. Come to the board. If force is like this and the point is this is the perpendicular distance. If the force is something like this and this, if this is the considered point, this is the perpendicular distance. If the force is like this and when the considered point is on it, what happened? If the force is this, if the considered point is O, this is the perpendicular distance. If the force is like this and the point is O, this is the perpendicular distance. And if the force is like this and this is the point, there's no any perpendicular distance. Then what happened? It becomes 0 and moment becomes 0. You have to understand that also. If you like, you can draw these 3 cases where it shows you how this perpendicular distance becomes 0 when the point is on the force. This is the point, this is the force, this is the perpendicular distance. If I bring closer this point O to the force, so the perpendicular distance will reduce. If I bring this point to the, if I bring this point to somewhere on the force, what will happen? The perpendicular distance becomes 0. Here, this is the perpendicular distance. Force is this, point is O. This is the perpendicular distance. If I bring closer this point O to the force, the perpendicular distance will reduce. If I bring this point to somewhere on the force, perpendicular distance is 0. Here in my sixth example, point O is on the force. So there's no any perpendicular distance between point O and force. So even though there's a F, D is 0. Moment will become 0. Okay? Okay, you can continue. I have to give you a stomach also. Okay, give me a small stomach. Give me a small stomach. Give me a small stomach. When the point, when the point O is on the force, when the point O within bracket, when the point O within bracket, when the point O, no, when the point O is on the force, when the point O is located on the force, when the point O is located on the force, there will be no any perpendicular distance when the point O is on the force. When the point O is on the force, there will be no any perpendicular distance. There will be no any perpendicular distance between that point and force. Between that point and force. D is equal to 0. D is equal to 0. And the moment will become 0. And the moment will become 0. D is equal to 0 and the moment will become 0. D is equal to 0 and the moment will become 0. D is equal to 0 and the moment will become 0. Here, if the point O is somewhere here, this is the perpendicular distance. If I bring it closer, perpendicular distance will reduce. If I bring the point O, or the point where I consider the moment, to somewhere on the force, D will become 0. 0 D value will create the moment 0. Okay, go to the seventh part. Go to the seventh part. This is a 15 Newton force. This is 15 Newton force with a perpendicular distance 3 meters to the point considered. Moment is equal to force into perpendicular distance 15 into 3 Newton meters. Moment is 45 Newton meters. Meantime, keep an vertical object on the perpendicular and apply the force that they have given to it, that they have given onto this hypothetical object, and check the rotation, something like this. So this moment is anti-clockwise. It's a clockwise rotation. Why? ඔරලෝසය කටු මෙහෙම කරගෙන මේ ඔරලෝසය කටු මේ 8 9 10 11 12 මේ ඔරලෝසය කටු මේ 8 9 10 11 12 කරගෙන. It's a clockwise moment. Okay. Eighth part. There's a 4 Newton like this, and point O is somewhere here. You can't draw a perpendicular. You can't draw perpendicular to the force. Force is somewhere else. You can't draw perpendicular to the force. Draw the line of action of the force. Continue the line of action. Continue the line of action of the force and draw perpendicular to that. If you can't draw perpendicular to the force, don't take that distance as the perpendicular distance. What you have to do? You have to continue the line of action and draw a new perpendicular to that line of action. It is the D, and it's equal to 2 here. So what will be the torque? F into D, 4 into 2, 8 Newton meters. Here, keep the hypothetical object on the perpendicular. Keep your hypothetical object on the perpendicular and apply the force that you are asked, and check the rotation of that object. Keep the hypothetical object along the perpendicular and apply the force that they are asking, and check the rotation of the object. It's a clockwise rotation, so this moment is the clockwise one. They will not show that object. They will just give the force and the length. You have to keep that hypothetical object, one end pivoted on O and other end along the object along the perpendicular, and apply the force given and check the rotation of that hypothetical object. It will provide you the clockwise or anti-clockwise rotation. Okay, the final one, the ninth one. There's a 12 Newton force. There's a 12 Newton force, and point O is somewhere here. What is the torque? What is the torque? Okay. So this is the situation. This is the situation. Now, if you can't find a relationship with the force and this point O, I have always asked you to continue its line of action. When I continued the line of action, I saw that point O is on the line of action. Okay? So there's no any perpendicular distance. That's what has happened. So is equal to FD, where D is the perpendicular distance to the force or to the line of action. Now the O is on the line of action. So even though there's a F, there's no D. Torque will be 0. If you can't find a relationship between this point O and the force, I ask you to continue the line of action of the force. And that line of action will give you the, after you draw the line of action, you can draw the perpendicular from O to that line of action. Now in this case, the line of action is moving over the point. Its point O is on the line of action. So the D stands for the perpendicular distance between the line of action and O. So there's no any perpendicular distance between line of action and O. O is already on the line of action. So D is 0, torque is 0. Give me a small star mark. Give me a small star mark. If the point O is on the line of action, if the point O is on the line of action, then again the moment will become 0. If the point O is on the line of action, then again the moment will become 0. If the point O is on the line of action, then again the moment will become 0. If the point O is on the line of action, then again, if the point O is on the line of action, then again the moment will become 0. If the point O is on the line of action, then again the moment will become 0. Okay, I'll give you 2-3 minutes to go through all the points that I have taught you. I'll give you 2-3 minutes to go through all the points that I have taught you before going to the next topic. You need to revise these points before I give you the next topic. What is the moment? Then how it is calculated? What is the physical meaning of the moment? And how the distance, how the perpendicular distance is found? And what is this clockwise and anti-clockwise manner? Go through all these things, the star marks. Okay. Now, these are the points that I have given to you. What is moment? What is moment or torque? What is moment or torque? It's the ability to rotate. What is moment or the torque? The physical meaning. It's ability to rotate. How it is calculated? How it is calculated? When an object is kept like this and it's pivoted from a point O, if you apply a force F, you have to take the perpendicular distance to that force from the pivoted point. Torque will be calculated by F into D and measured by Newton meters. Okay? And if a force is applied like this with respect to the pivoted point, say this is a hypothetical, this is an object, it will rotate like this. So it's a clockwise moment. Now, in the other hand, if the object is like this, and from the same perpendicular distance D, if a force F is applied like this, object will rotate in the other hand. So torque is equal to Fd, no matter on the magnitude, but it will rotate in the other manner. So it's a anti-clockwise. This is the anti-clockwise motion. This is the clockwise motion. So it will be an anti-clockwise moment. Okay. Now, when we come to questions, they will not give you an object. They will give just the force, let's say 5 newtons, and the point O that you have to consider the moment. In such a case, keep a hypothetical object along the perpendicular and apply that force physically and check what happens. It will rotate like this. This hypothetical object will rotate like this. So it's a anti-clockwise moment. What's the value? F into D. 5 into, say, 2 meters, 5 into 2. 10 Newton meters. And there are some special cases when the force is like this. Point is somewhere here. So even though you try to draw a perpendicular, you can't draw a perpendicular. In such a case, continue the line of action and draw a perpendicular to the line of action. That's what you have to do. And torque will be equal to F into that perpendicular which is drawn to the line of action. Okay. So to find whether it's clockwise or anti-clockwise, keep the hypothetical object on the perpendicular, not on the other lines, on the perpendicular, and apply the force. Then you will see it. It's a clockwise. It's a clockwise moment. There are two other cases also. If the considered point O is passing the force, is on the force, what happens? Always the perpendicular distance is the perpendicular distance is from O to the force. If you bring the point O closer to the force, the perpendicular distance will reduce. If you bring the point O on the to somewhere on the force, what will happen? D will become 0. Then moment will become 0. Not only that, force is somewhere here. The force and the point is somewhere here. You can't find anything, but as I have said to you, continue its line of action. Then if you can see whether this force is passing the line of action, this point O is on the line of action, again what will happen? F into D, even though you have F, you don't have a D. Why? Sometimes D is the perpendicular distance from force to point O. Sometimes D is the perpendicular distance from line of action to point O. Here, the point O is on the line of action, so you don't have a gap between the line of action and O. D is 0. Moment. So these are the things that I have told you. And write a small topic now. Direction of the moment. Now you know how to understand whether the moment is anti-clockwise or clockwise, but it's not the direction. Now there's a subtopic. Direction of the moment. Direction of the moment. It's something else. Direction of the moment. Direction of the moment. Wait, this is point O. This is the force F. Okay. Now, this is what you have to do. First, understand whether this moment is clockwise or anti-clockwise. This is the point O. I will keep the hypothetical object along the perpendicular. This is the point O. I will keep the hypothetical object along the perpendicular and I will apply this force physically. Then I can see object will move like this. So this force is anti-clockwise. This force causes an anti-clockwise moment. So the moment is anti-clockwise. Wait. Now take your right hand. Now take your right hand and keep your thumb separately and bring the keep the other fingers. Anit ඇඟිලි ටික මේ clockwise ද anti-clockwise දෙක දිගේ තියන්න. හරි මේ පැත්තටනේ අනිත් ඇඟිලි ටික මෙහෙම තියන්න. then ඔයාගේ thumb එක පෙන්නනවා මෙන්න මෙහෙම outer direction එක. ඒක තමයි moment එකේ direction එක. හරි direction is something like this. මේකෙන් කියවෙන්නේ මොකද්ද? පොතෙන් එළියට out of the book. ඉතුරු ඇඟිලි ටික අරගෙන ඉතුරු ඇඟිලි ටික තියන්න clockwise ද anti clockwise ද කියන එක දිගේ. thumb එකෙන් පෙන්නයි direction එක moment එකේ. මෙන්න moment එක පොතෙන් ඉවතට. මොකද්ද සර් ඒ? මොකද්ද සර් ඒ කියපු දේ? Wait, I will explain. Wait, I will explain. First we have to draw, then I will explain very clearly. Another example. This is the point O and this is the force F. First, judge whether this is a clockwise or anti-clockwise moment. Keep the hypothetical object like this along the perpendicular. Then you will see when you apply force into this, force into it like this, it will make a rotation like this. So this is a clockwise moment. හරි දැන් අන්නේ මොමන්ට් එකේ පැත්තට මහ පොට ඇඟිල්ල ඇරෙන්න දකුණු අතේ ඉතුරු ඇඟිලි තියන්න. දැන් අන්නේ මොමන්ට් එකේ පැත්තට මහ පොට ඇඟිල්ල ඇරෙන්න දකුණු අතේ ඉතුරු ඇඟිලි තියන්න. මහ පොට ඇඟිල්ල යනවා පොත ඇතුළට. පොත ඇතුළට යනවා. to the book. හරි? direction එක මේකයි. පොත ඇතුළට යනවා. මේ ටික complete කරගන්න ඊට පස්සේ මේ මොකක්ද කියපු එක කියලා මම in detail කියලා දෙන්න. මේක කියා දෙන්න වෙන්නේ කරගත්තට පස්සේ. ඇඳ ගන්න බලන්න. කාට හරි මේක අඳින අතරේ කවුරු හරි කැමතිද ස්ටේජ් එකට ඇවිල්ලා මේක අනික් යාළුවන්ට කියා දෙන්න. මට තේරුණා කියලා. ඇඳ ගන්නකො. ඇඳගත්තට පස්සේ කවුරු හරි කැමති නම් ස්ටේජ් එකට ඇවිල්ලා මං කියා දෙන්නම් මගේ අනික් යාළුවන්ට මේ කියන්නේ මොකක්ද කියලා. ස්ටේජ් එක බාරයි. ඒ අතරේ එහෙම කියා දෙන්න බලාපොරොත්තු වෙන්නේ නැත්නම් මට දෙන්න වතුර බෝතලයක් මං කියා දෙන්න. ඉතින් වතුර බෝතලයක් තියෙනවා. ඕකේ. බලමු මේක මොකද්ද මගේ වැඩේට ගැලපෙන්නේ කියලා. මේක හොඳයි වගේ මොකද මේක මට අතට ගන්න පුළුවන් පොඩි ඩිවයිස් එකක්. වතුර ටික හැබැයි හල්ලම ඉල්ලගත්ත වතුර බෝතලේ. ඕගන්න. කෙලින්ම ආයේ උණු වතුර බෝතලයක් දීලා තියෙනවා. හරි. කලබලයක් නැහැ මේක මොනවා හරි ලියා ගන්නකොට ටිකක් පස්සේ වැරදි හදාගමු කියා දුන්නාට පස්සේ තාම තේරෙන්නේ නැතුවනේ ලියන්නේ ඒ නිසා නිකන් අවුල්. Direction of the moment. So this is point O and draw a perpendicular line and this is force F. Okay. Now first you have to judge whether this moment is clockwise or anti-clockwise. Keep a hypothetical object on the perpendicular and apply the force given. Then you will see the object kept will rotate in an anti-clockwise manner. So this is a anti-clockwise moment about point O. So moment is anti-clockwise. හරි. දැන් ඔයාගේ දකුණු අතේ මේවා ලියමු මේ නෝට් එකෙන් පස්සේ ලියමු. ඔයාගේ දකුණු අතේ ඉතුරු ඇඟිලි ටික මොමන්ට් එක මේ clockwise ද anti-clockwise ද කියන පැත්තට හරවන්න thumb එක මෙහෙම තියාගෙන. එතකොට thumb එකෙන් පෙන්නනවා direction එකක් පොතෙන් එළියට outside the book. So direction is outside the book. We'll write them one by one. Before that you have to complete this diagram. මෙන්න point O එක තියෙනවා. මෙන්න force එකක් තියෙනවා F කියලා දාපු. perpendicular distance එක දාගන්න point O එක මෙන්න force එකක් තියෙනවා perpendicular distance එක දාගන්න. හරි. එතකොට මෙන්න moment එක හරි hypothetical object එක තියන්න force එක දාන්න. hypothetical object එක මෙහෙම කැරකෙයි. මෙන්න moment එක clockwise කැරකෙන්නේ clockwise moment එක. ඒ අතට ඔයාගේ දකුණු අතේ ඉතුරු ඇඟිලි ටික යොමු කරන්න. එතකොට thumb එකෙන් ඔයාලට පෙන්නයි පොත ඇතුළට. So the direction of the moment is to the book. මොකද්ද මේ කියපු බහුබුද්ධ කතාව? දවසමත් හරි මේකත් හරි මෙලෝ දෙයක් තේරුනේ නැහැ. තේරෙන්න කියලා දීලා ඉවර නැහැ. මේ ටික ලියන්න ඕනේ ඉස්සෙල්ලා. හරි. දැන් චුට්ටක් බලමුද එහෙනම් ඉක්මන් කරන්න නැත්නම් වෙයි. පොඩ්ඩක් බලමුද අපි පොඩ්ඩක් මේක. මොකද්ද මේ කිව්වේ කියලා. හරි වැඩ නවත්තන්න. හරි. දැන් මේ බලන්න පුතේ මෙන්න මේ බෝතලය. මේ බෝතලයට කැරකෙන අතට මං ඉතුරු දකුණු අතේ ඉතුරු ඇඟිලි ටික දාන්නම්. මේ බෝතලේ මූඩිය කැරකෙන අත මොකක්ද? මෙහෙම දකුණු අතේ ඉතුරු ඇඟිලි ටික දැම්මොත් මේ අත. බලන්න ටික ටික මූඩිය කොයි පැත්තට දෙන්නේ කියලා. ටික ටික බෝතලේ මූඩිය කොයි පැත්තට දෙන්නේ? උඩට. This is the direction. කැරකෙන අතට මම දකුණු අතේ ඉතුරු ඇඟිලි ටික දාන්නම්. මුඩිය කොයි පැත්තටද යන්නේ? පහළට. ඒක තමයි මොමන්ට් එකෙන් ඇත්තටම කරන්නේ. ඒක නිසා ඒක තමයි ඩිරෙක්ෂන්. මේ ආයෙ. මෙන්න මුඩියක් තියෙනවා. මේකට ෆෝස් එකක් දාලා මොමන්ට් එකක් හදලා කැරකෙන අත බලා ගන්නවා. මෙහෙම ෆෝස් එකක් දාලා මොමන්ට් එකක් හදලා කැරකෙන අත බලා ගන්නවා මේක. මේ අතට කැරකෙන. මෙන්න මේ අතර කැරකෙනකොට වෙන දේ ටිකකින් මූඩිය එළි. This is the result. මෙන්න බාණ්ඩේ මෙහෙම ෆෝස් එකක් දාලා මෙතන perpendicular distance එකක් තියෙනවනේ. මෙහෙම force එකක් දාලා මෙතන perpendicular distance එකක් තියෙනවනේ center එකේ ඉඳලා moment එකක් හදා ගන්නවා. පැත්ත හොයා ගන්නවා. මෙහෙම. ඕ. කොහෙටද මුඩ යන්නේ? පල්ලෙහාට යනවා. ඒකයි උනේ. හරි? පොඩි වාක්‍යයක් දෙන්න. Take your right hand. Take your right hand and align the other fingers. Take your right hand and align the other fingers with the rotation. Take your right hand and align the other fingers with the rotation. Keep the thumb perpendicular to the other fingers. Keep the thumb perpendicular to the other fingers. Keep the thumb perpendicular to the other fingers. It will give you the direction of the moment. It will give you the direction of the moment. It will give you the direction of the moment. It will give you the direction of the moment. I'll tell again. Take your right hand and align the other fingers with the rotation. Take your right hand and align the other fingers with the rotation. Keep the thumb perpendicular to the other fingers. It will give you the direction of the moment. Within brackets, write the name of this rule, right hand screw rule. The name of this rule, right hand screw, S-C-R-E-W, screw rule. මොකද screw එකක් තුනේ ඕකමයි. Within brackets, right hand screw rule. Screw එකක් අරගන්නේ කොහොමද? Right hand screw rule. So that is the direction of the moment. It's not whether it's anti-clockwise or anti-clockwise, it's the pattern of the rotation, and direction is something else. Okay. Okay, I'm going to explain that part again. Now we are going to find the direction of the moment. First, what you have to do, this is the force, this is the point O. Keep the hypothetical object along the perpendicular and apply the force and check whether it's anti-clockwise or clockwise. Here, if this is the perpendicular distance, this is the force. Kept the hypothetical object like this, applied the force, it's rotated like this. This is the anti-clockwise moment. Here, if it's the point O, perpendicular distance D, force is F. Keep the perpendicular, keep the hypothetical object along the perpendicular, check with the force, it will rotate like this. So the rotation is in the clockwise manner. Now you need to find the direction of the moment. Okay, first understand the pattern. Here it's a anti-clockwise moment. Okay, so let's consider what happened. This is anti-clockwise moment. Align your other fingers. Align your other fingers with the rotation and keep the thumb perpendicular. It will show you the direction of the moment outside the book. Align your other fingers with the rotation. Keep the thumb perpendicular to them in your right hand. In your right hand, align the other fingers with the rotation. Keep your thumb perpendicular to the others. It will give the direction of the moment. Why is that? This rule is known as right hand screw rule. Why? This is same that happens in a screw. So this is the object. It has a center. From center, there's a perpendicular distance. I'm applying a force. So there's a moment. It will rotate like this. When it rotates like this, it will finally end up with something like this. There's a center. From center, there's a perpendicular. And I'm applying a force like this. It will create a moment in this manner. So I align my fingers into that direction, that pattern, and this will go down. This is what moment does. So that's why it's known as direction. Okay. Next subtopic. Finding the moment of a finding the moment of a force system. Finding the moment of a force system. Finding the moment of a force system. Find moment of a force system. Finding the moment of a force system. පුතා මට මේ මාතෘකාව ඉවර කරන්න බෑ. ඒ නිසා මම මේ මාතෘකාව ඔයාට තේරෙයි කියලා කම්ප්ලීට් කරන්න යන්නෙත් නෑ. මොකක්ද මම කරලා දෙන්න ඕනේ? විනාඩි 10ක් තියෙනවා. චුට්ටක් කියා දීලා next week මොලේ ඉඳලා කියන්නද නැත්නම් පන්ති ඉවර කරන්න. අපේනුත් අහනානේ මේ වගේ ප්‍රශ්න නේද? හරි. මොකද්ද කරන්න ඕනේ? කියලා දුන්නයි කියලා ලොකු වැඩක් වෙයි කියලා නම් හිතන්නේ නෑ. මොකද මේක තරලි යන්න ඕනේ. මේකට පැයක්වත් ඕනේ. මොකද කරන්නේ? විනාඩි 10ක් තියෙන මොනවා හරි ටිකක් කියන්නද? පොඩි කියන්නේ මුල ටික නම් කරන්න බැරි කමක් නැහැ. නමුත් ඉතින් ඔය ටියුට් එකේම ගණන් ටික තියෙන්නේ ඒකෙන් ඊළඟ. හරි විනාඩි 10යිනේ තියෙන්නේ. පටන් ගත්තට කියලා ඉවර කරන්න බැරුව විනාශයක් වෙන්නේ නා. ඉතිහාසයේ ප්‍රථම වතාවට විනාඩි 10ක් කලින් පන්ති හරින්න යන්නේ ගිනස් වාර්තාවක සමගින් ජීවිතේ ප්‍රථම වතාවට නම් මන්ද. හරි නෑ ඒක නෙමෙයි. එහෙම ඉඳලා හිටලා වෙන ඔය දේවල්. මේ තේරුමක් නැහැ. හරි. දැන් ඕක කියලා ඔය යට තියෙන ගණන් ටික F වෙනකල් හදලා ඊට පස්සේ ඔතනින් යනවා පුතා දිගටම. ඕකම තමයි මේ බේස් එක. ඉතුරු ටිකේ ඔක්කොගෙම. හරි. ඉන්න. විනාඩි 10ක් ඉන්න කමක් නැහැ. හැපිද? හැපියා? ඒ කියන්නේ තේරුමක් නැති වැඩ කරලා වැඩක් නැහැනේ. මොකද හරියට ලබන සතියේට වෝම් අප් වෙන්න තියෙන්න ඕනේ. ඇති. ඉවර කරනවා ඈ. නා. වයිත් බෑ නිකන් පන්තියක් කරලා කලින් ගෙදර යන්න. අමුතු ගතියක් දැනෙනවා. හරි? නා. කමක් නැහැ. මොකද හේතුව මේ next week එක පරිස්සමට එක ගන්න ඕනේ. ඔන්න විනාඩි 7ක් කලින් පන්ති ඇවිල්ලා. හරි වැඩ ඉවර කරනවා එහෙමනම්. ඒක කරන්න බලාපොරොත්තු වෙනවා. හරි මේ Thursday practicals දෙක කරන්න බලාපොරොත්තු වෙනවා. එක practical එකක් තියෙන්නේ force parallelogram law එකේ. අනික තියෙන්නේ friction වලින්. හරි? force parallelogram law එකේ friction වලින් තියෙන්නේ. එතන මේ Thursday evening group එකේ විස්තර වැටෙනවා බලන්න. මේ සතිය අපි පේපර් එක ලිව්වේ නෑනේ. මේ සතිය අපි පේපර් එක ලිව්වේ නෑ. අපි Thursday ඩිස්කස් කළේ කලින් පේපර් එක. මේ සතියේ පේපර් එක ලිව්වේ නෑ. ඒ වෙනුවට මේ Thursday 8:30 අපි මොකද්ද කරන්නේ? ප්‍රැක්ටිකල් ඩිස්කෂන් එක කරනවා. ප්‍රැක්ටිකල් ඩිස්කෂන් එක කරනවා. මෙකැනික්ස් වල අහගන්න ළමයි. මෙකැනික්ස් වල ප්‍රැක්ටිකල්ස් තියෙන්නේ ඔය මම කරන්න යන ප්‍රැක්ටිකල්ස් දෙක තියෙනවා. ඊට පස්සේ ආයෙ ප්‍රැක්ටිකල්ස් තියෙන්නේ අගින්. හයිඩ්‍රෝස්ටැටික්ස් වලින්. ඒවා මේ ටර්ම් එකේ ඉස්කෝලේටවත් කියන්නේ පුදුම වේගෙන් ගිහිල්ලවත් ඉස්කෝලේ දෙන්නේ නැහැ. හරි? එතකොට මේ ටර්ම් එකට ඔය ප්‍රැක්ටිකල් දෙක එනවා. මේ ටර්ම් එකේ ඊළඟ විභාගයට ඔය ප්‍රැක්ටිකල් දෙක එනවා. තේරුණාද? එතනින් එහාට ඉස්කෝලෙන් මැද්දෙන් පාඩම් පැන ගියත් එතෙන් දෙන්නේ නැහැ. ඔච්චරයි සීමාව. ඒතර මේ දෙක ඉවර කරගන්න ඕනේ. හරි? එහෙනම් මේ වැඩේට Thursday යමු වෙන්න. හරි? ඒ ටික තමයි. එහෙනම් යන්න පුළුවන් පරිස්සමෙන් යන්න වැටි කරගන්න. හරි.